tape that was on this?
I just...
Oh, can you leave it on there? It's colour coding.
Yeah, no worries. Oh, I can take it off without... Oh,
Yeah, you don't need to take the tape
I
off.
thought the tape was holding the back of the...
Yeah. For a speaker, I might have to replace it though because I'm not sure if it's... Testing 1, 2. You should be able to hear yourself through here. Is it off? Should be on. One. There we go. 1, 2, 1, 2. So you'll be able to... Won't have the delay won't be as distracting.
Yeah.
Hopefully.
I mean, we got used to it in 10 minutes.
Yeah.
Pretty off-putting in the beginning of the build.
Yeah.
Oh, yeah, okay. We'll just wash it out.
Yeah. And hopefully you shouldn't cut out too much. You at least won't cut out through your own hearing, so.
Yeah. Nice.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
Good morning, everybody, and welcome to day 2 of the Australian Rover Challenge 2025. My name is Georgia, and I'm joined here again by Shagaf today, and we will be your commentating team among some new members throughout the day.
Yeah, this is looking like an exciting day, another incredible series of events that we're going to be expecting here at the University of Adelaide Roseworthy campus. The sun has just risen and it's wonderful weather so far. I'm hoping that the afternoon is not as warm as yesterday was. There's some clouds, so we're hoping that the radiation isn't as too bad. A bit of introductions first. My name is Shagaf, like Georgia just mentioned. I'm completing my honours in mechanical engineering, majoring in aerospace at the University of Adelaide. And I've had the privilege of being involved in several extracurriculars throughout my degree, including being part of the Adelaide Rover Team, where I participated in this challenge in the year 2023, which was an incredible experience. And amongst others were the Adelaide University Space Society, the Adept Rocketry Division, and the Astro program.
Similarly, I also studied aerospace engineering and computer science at the University of Adelaide, just graduated, and now to be working in the space industry, it's a pretty exciting experience. And I've had the opportunity to be part of the Adelaide Rover team since the very first challenge all the way back in 2021. And I think this is a good time to acknowledge that this is the 5th iteration of the Australian Rover Challenge. And my gosh, the competition has just continued to grow. We started with 3 teams in the first iteration on the University of Adelaide's North Terrace campus in the CBD, and it's continued to expand, and we now have 2 pitches down at the University of Adelaide Roseworthy campus in South Australia. line.
Absolutely. And this is also a good opportunity to take to acknowledge the lands that we meet on today, which are the traditional lands of the Kaurna people, the Adelaide Plains. So I extend my respect to their elders, past, present, and emerging. So we will be putting up a leaderboard on the board there, a scoreboard. Which you'll see some of the scores accumulated from yesterday. Now, it is worth noting here that this is not fully updated from all the tasks yesterday, so this is only the teams who have completed the post-landing task have had their scores updated. The space resources task will need to be weighed at the end, so that will only be accumulated into the scoreboard once all the teams have completed the space resources task.
So in a tentative pole position, we have AGH Space Systems here all the way from Poland, and they actually scored a perfect 100 out of 100 on the post-landing task yesterday.
With 4 minutes to spare.
4 minutes to spare.
That was an incredible display.
So they're currently the only team to get perfect points on this task. Will we see it again today? That's going to be the question. We've got such an exciting lineup for you all this morning. First off, at 9 a.m. on pitch A for the post-landing task, we have Project Scorpio coming all the way again from Poland. And on pitch B, we have another Polish team, AGH Space Systems, the current reigning champions. So that is going to be very exciting. We can maybe give a bit of a rundown.
We
of the
absolutely
tasks.
should. I mean, if you tuned in yesterday, you'll be familiar with what's going to take place on these pitches. So very similar tasks. Pitch A will have the post-landing task, and on pitch B we have the space resources task. A bit of a quick overview. So the post-landing is simulating a scenario where your rover has just landed on the lunar surface, and it's required to do a bunch of systems checks, and it's required to rove around, check for damage, and do some processing and fix some host connections as well. So that'll be happening on pitch A. We already have, looks like Project Scorpio is ready to go as soon as that timer starts ticking off in about a minute as they place their rover there on that ramp. So the first set of points will be achieved as soon as this rover is able to descend down that ramp successfully and all 4 wheels are on the ground. That'll give them the first set of points. The activities in the remaining of the tasks can be done in any order, and they involve roving around to check for damages, read out some status messages on the screens around the pitch, as well as roving over to the processing plant where there's some buttons, a keyboard, and other knobs that they need to complete. So that's the post-landing task, which will be kicking off in under a minute. As you can see there's a 40-minute countdown ready to go. So they have 40 minutes available to complete this task, and there's up to 100 points available to achieve if they do complete all the tasks successfully.
So they'll be getting underway in less than a minute now, and this is the base station team. So if you're just joining us here this morning, the teams are often split into two. There will be a field team and a base station team. So the base station and the field team are allowed to talk to each other while the team is setting up their rover. And as soon as the field team initiates the task start, they cut off that two-way communications, and they're not allowed to talk to each other unless there's an issue. And they call an intervention, which will result in a penalty.
Yeah, and we did see some interventions called yesterday. Some teams needing to call multiple interventions, which is allowed and sometimes necessary if the rover gets bugged and is not able to move, if the rover is experiencing some technical issues or the connection is not established properly. An intervention sometimes is necessary, even though there might be a deduction of points, to get that rover troubleshooted, back up and working, and use the remainder of time to achieve as many points as possible.
Absolutely, and take some real coordination between the base station team and the field team to be able to get that right, to be able to understand the problems going on at the field and the base station when they can't talk to each other. So it's a real teamwork activity.
So as we can see there, the countdown has officially started for 40 minutes, and we already have movement. Round of applause as we have the first rover descending down the ramp today here at the second day for the Australian Rover Challenge 2025. This is Team Scorpio, or Project Scorpio Rover Team from Poland.
They're not wasting any time this morning, are they?
There's their first set of points achieved.
All 4 wheels on the lunar surface. Where are they going to go next? So the teams can do the tasks in this challenge in any order. So there's a reminder for us all there. Systems check, site evaluation, wireless communication, processing plant maintenance, and the hose connections. So all of the teams were required to design their own hose connector, which can interface with one of the pieces of equipment on the surface. So we might see that a little bit later. And that's Project Scorpio's GUI, or Graphical User Interface. So this is what the team in the base station sees. Now, really critical aspect of this challenge is that the team in the base station cannot see the field. So just like a real-life space mission, they're relying entirely on their communication system on their rover and the 2 or multiple camera feeds that they might have available. So they see what the rover sees.
And this is really to simulate that real-world scenario when we do send lunar rovers or even interplanetary rovers to other planets. It's really just the reliability on that communication system. In real life as well, you have a time delay. So if you were operating a rover on Mars, there's up to a 20-minute time delay between when you send the instructions, you have to wait 20 minutes. And if you want to receive information from a rover on Mars, you have to wait another 20 minutes. So that's something that's not simulated here, but in real-world scenarios, there is that time delay when we talk about space exploration and rovers on other planets.
So they might be trying to read a status message there, potentially somewhere on the back of the lander. The teams will be required to read this status message, relay it to the judges correctly to get some points.
While we all carefully watch Project Scorpio attempt its post-landing task, we'll give you a bit of an overview of the rest of the teams expected here today. So on pitch A, where the post-landing task is taking place, we've got Project Scorpio, which is ongoing at the moment. Shortly afterwards, we'll have Bluesat, which is a team actually competing in this challenge for the first time as well, from Poland as well. So a really big representation from Poland this year. After Bluesat, we'll have Deakin University, followed by Adelaide University, and then QUT Roar. And that's the teams that make up the schedule before the lunch break today. Then over at pitch B, where the space resources task takes place, we're expecting AGH, the Polish rover team, as well, in about 10 minutes to begin their space resources task over there, followed shortly by UOW, UQ Space, and then UTS, all of that before the lunch break today.
Some nice use of Project Scorpio's robotic arm here this morning. We talked a lot yesterday about all of the different components that make up this type of subsystem. The linkages, the end effector, and the multi-material manufacturing that we often see. Lots of teams like to make use of really cutting-edge manufacturing techniques. We saw what we thought was a bit of generative design yesterday, and we've seen a lot of 3D printing on many of the rovers.
We also talked a lot about a concept which is called biomimicry, which is where we, in technology and machines, we try and replicate natural wildlife or even the human body. And this is something that actually we can see here with these robotic arms, getting those multiple joints and multiple degrees of freedom to almost get what a human arm can do or a human hand can achieve is really critical here, especially if you've seen some of the tasks where the rovers approach the processing plant and they need that really precise maneuverability to be able to hit those knobs and buttons.
The fidelity is insane, and we had an interview yesterday with Dr. Jason Armstrong from Boeing, and he talked a lot about how we need rovers to be able to traverse extreme environments before we send humans there, reducing the risk, increasing the efficiency of missions, and of course making sure they're extremely safe. And so being able to have a robot which has that same fidelity as what a human hand has, that only increases the success of possible missions in the future.
So really exciting attempt here. We can see that Project Scorpio rover has picked up one of the host connections. So for a reminder, the post-landing task does have 2 host connections that they need to be able to make or to connect to achieve a set of points. And it seems like they're going for one of those host connections at the moment. They've successfully picked up one of the host connections, and they're going to attempt to make that connection. Now, just a reminder, they will receive some points if they make those 2 surfaces touch. So even if they don't successfully connect that host connection, if the 2 surfaces touch each other, that does give them some points. But of course, if they make a successful connection, that will give them a complete set of points.
An incredibly detailed GUI there from Project Scorpio. You'll notice that all of the teams have got their own unique flavor to how they display the data that they need. We talked a bit yesterday about how important it is to have a nice balance between visual information and also data coming back from your rover. You always want something called redundancy in these types of systems. When we're going to space, it's pretty hard to find a way to maintain your device. You can't just send a crew out there readily to go repair something. Even though we have a field team here in this competition, in real life, you need redundancy. So if any of the team's cameras were to fail, they might need to rely on the status readouts from other systems to understand what's gone wrong.
A moment of suspense is building up here as Project Scorpio Rover Team is continuing to attempt to make that host connection on the lander there.
Some intense concentration from the base station team there. They have to know these systems inside and out without being able to see them on the field.
This is actually something incredible that I haven't seen with the other rover teams, GUI or interfaces, is they've actually got a holistic view of the entire rover and what it's doing as it's operating live.
So we're looking in the bottom left corner, that rover visualization tab.
That's something, that's the first time I've seen something like that.
So they sometimes refer to this as a digital twin. Perhaps they're testing some computer vision elements on board their rover. Later this week, there's a mapping and autonomous task, which requires the rovers to operate semi-autonomously or fully autonomously. So using computer vision cameras to be able to generate a 3D map of the terrain will allow the rover to navigate it by itself.
And the crowd watches closely as Project Scorpio approaches the connection. It seems like the two surfaces did touch. So
very careful, precise movements are needed in this competition more often than not. These operators in the base station often have to train for many weeks to be able to understand the rover system and just how much control is needed to complete tasks like this.
And worth noting, I can see some zip ties coming out of that robotic arm or that end effector there, which is quite incredible and a really good reminder that these rovers that we're seeing in this challenge are fully student designed and built by these undergraduate and postgraduate students who are dedicating their spare time to do that. So an incredible combination of that determination and passion for a project like this.
Absolutely. Speaking to some of the teams, some of the students are in their first or second year of university. So for many people, and this was also the case for me when I first joined the Adelaide Rover team, it was one of the first experience I had of a hands-on engineering practical. And to be able to say you've built a rover, it's pretty crazy. It's a very good place to start.
It is quite incredible, particularly here in Australia as we see the space industry continue to grow.
Absolutely. This task this morning you might have seen is sponsored by a consortium known as ELO2. And if you haven't heard of them, definitely look them up. They are going to the moon. Supported by the Australian Space Agency, ELO2 will be building Australia's first ever Lunar Rover, affectionately named Rover, named by the Australian public.
And this is a good opportunity to talk about that this initiative, this competition, which started 5 years ago by the University of Adelaide. One of its main goals is to address, the future, to build that future space workforce, but also to address Australia's involvement with the Artemis program, the Moon to Mars initiative, and that involvement that support is that first Australian lunar rover, which will be provided by the Australian Space Agency for NASA to go with one of NASA's Artemis programs, heading to the moon sometime in the next 5 to 10 years, they say, which is pretty exciting, having the first Australian lunar rover touch down on the moon, but also being part of such an incredible mission, the Artemis program.
And indeed, some of the students who have competed in the Australian Rover Challenge previously have actually gone on to work on this lunar rover. Can you believe that? What an exciting career to possibly start with out of university.
And we've talked a lot about the experience that these students get, and we say that it's not always about the points that you get in these tasks or the leaderboard. It's really about that valuable experience. And even in the times when things go wrong, that's when you're learning the most valuable lessons to learn, to develop, to make things better. All that experience these undergraduate and postgraduate students are getting is really, really valuable and makes them stand out from their other classmates who may have not pushed themselves out of the comfort zone to get involved with projects like this, which is just incredible.
So it looks like Project Scorpio are on the move. They've emerged from behind the lander. Let's see where they're going to go next.
So while Project Scorpio is roving around on pitch A, we have ticked over 9:15 a.m. local time, which means over at pitch B, we have AGH Rover Team from Poland as well. And it looks like they've already initiated their space resources task. Incredible work, heading off straight as the countdown has initiated. So we've talked a little bit about what the post-landing task is happening here on pitch A. Georgia, do you want to tell us what space resources is and what we're expecting to see AGH hopefully do over there?
For sure. So for anyone who might not be familiar with the idea of space resources, why do we care about it? Just like Shagaf was saying earlier, we have this set of Artemis missions to return to the moon. And one of the key objectives of going to the moon is to understand what is inside the lunar surface, what's in the regolith. We're looking for the building blocks of life. We're talking water, we're talking oxygen, and other sorts of volatiles. Now, We believe that some of these volatiles are contained in places called permanently shadowed regions. These are almost like the insides of craters on the lunar surface that don't get to see the sun, so they're permanently shadowed, meaning that the regolith in there, also known as the lunar soil, is cold enough that it freezes over and it could potentially contain water. And we're pretty confident that it does, and there are missions being designed to go to these places on the lunar surface and confirm if that's true. So these rovers are doing our own version of this task. They're going to traverse around the lunar surface, examine some sites of frozen regolith, prospect them, so take an image. Looks like that might be what AGH Space Systems are doing at the moment. And then they're going to try and extract some of the frozen regolith. Now this is pretty incredible. All of this happens on board the rover. The prospecting, the extracting, and even the analysis component. So the aim of this task is to determine which of the sites has the most amount of water content in it, extract a core sample, analyze it, and then the team, immediately following the completion of this task, will be required to give a presentation to a panel of experts about what they found. Again, mimicking real life, this is exactly what would happen in a mission of this kind in space.
And there's that incredible view of the AGH Rover team. We've seen that rover demonstrated yesterday in the post-landing task, and I'm really excited to see how they complete the space resources task. We've talked a lot about their design approach, particularly the incredible precise movement of that robotic arm, those degrees of freedom that you can see there on the motors, on that end effector, and just incredible work by the AGH Rover team.
So the rovers are testing this idea of in-situ resource utilization. So meaning that when we travel to the moon or we travel to other planetary bodies, we want to be able to use the resources that are there. It's expensive, it's costly, and it's risky taking all of these resources from Earth, and we don't want to do that. So if we can utilize what's on another body, then that will enable the potential for sustained human presence on another planet or another moon, which is pretty exciting stuff to think about, and it's not that far out of reach.
It seems there's an attempt here by the AGH Rover team to extract some of that sample. An incredible display or demonstration of that end effector. They're almost trying to scoop up some of that lunar regolith.
Now, the Australian Rover Challenge is one of the most difficult and the most exciting rover challenges in the world. You might have seen yesterday AGH Space Systems absolutely tearing it up in the post-landing challenge. But that is not all you'll see from all of these different teams throughout the week. They have to be able to design something that can traverse the lunar surface, interact with equipment, excavate sites, build things from lunar bricks, prospect, operate semi-autonomously and potentially autonomously as well. And all of those systems take time and effort to develop. So sometimes teams opt to go for maximum points in certain tasks and forego other tasks so that it could be a development point for the following year.
Incredible job by AGH Rover team there. Seems they've picked up that sample tub. And just a reminder that we still have Project Scorpio Rover Team, another team from Poland. So really just a great morning to kick off the second day of the Australian Rover Challenge. 2 international rover teams competing on the pitches to kick off the day. Over here, we still have Project Scorpio completing the post-landing task. It seems they've approached the processing plant. And there are a number of tasks that they can complete at this plant or at this site. Each allocated a set number of points. And just a reminder, there are 100 points available should they complete all the activities or tasks in this challenge.
It's incredibly exciting to have international teams joining us year after year. Poland have been a returning visitor, so we're so excited to have this here again at the 2025 Australian Rover Challenge. Shagaf talked a lot yesterday about how Artemis is really an international effort. There's a lot of collaboration behind these missions to go back to the moon and potentially onto other planets like Mars. And similarly, the Rover Challenge is also a really collaborative effort. All of the teams are super supportive of one another, and they love learning from each other too about who's got different approaches to tasks and how they've gone about the design philosophy for their rover. And that's why this international collaboration is so fantastic too, because we're reaching across borders to be able to get the best, most up-to-date, cutting-edge knowledge of how to build these types of rovers.
There's the AGH Rover Team base station who are completing the space resources task, still attempting to scoop out some of that sample, it seems, hard at work in that mission control room. Just a reminder that the teams competing or participating in the challenge are split into two, where they have a field crew out on the field and a mission control crew who is responsible for operating that rover. There's some lovely faces of that field crew there for AGH Space Systems team. Of course, there's no communication between the two teams. As soon as they initiate their task, the team inside the base station is not allowed to communicate with the team outside, and neither are they allowed to see what the rover is doing or the field. The only information they get, as you can see there on their monitors, is that live camera feed.
A very innovative approach here from AGH Space Systems. Again, one of the awesome things about these tasks is that you will see completely different approaches by all of the teams, even though they have designed their rovers to exactly the same rules and regulations. If you missed it yesterday, for example, the University of Wollongong deployed 2 rovers to operate simultaneously, one miniature one called Roo and a primary rover called Kanga, and it used a form of deployment called marsupial deployment.
Which they also nicknamed the pouch, and I think that was really adorable.
Really ties that metaphor all together. So there are really no 2 rovers alike in any sense. Teams also don't know what the track looks like until they arrive here for the first time either. They get some hints about the size of objects and potentially the height of some of the craters and things like that, but they really won't understand potentially the scale and also where things are situated until they arrive here on the Roseworthy campus in South Australia for the very first time.
I don't know, Georgia, but it seems they're trying to tip that tub over and spill out some of that sample, which is a different approach to what we've seen before. As, again, going back to all the different approaches and strategies to completing these tasks.
Yeah, I think you could be right. Looking at the size of the sort of scoop mechanism that they have, this might be the way that they can get to some of that precious frozen regolith.
And they've picked up that tub. What an incredible display.
So mighty.
A monumentous attempt, and the tub has been dropped now.
Never give up. There's always a second attempt and another attempt. There's still plenty of time remaining for AGH. Project Scorpio similarly have just under 15 minutes remaining. Plenty of time. When the rovers are stationary, you might think that they're not doing anything, but more often than not, there can be some deliberation and strategizing happening in the base station to be able to carefully plot their next moves and really maximize their time available to get as many points as they think they can.
We've mentioned yesterday as well that you commonly or more than often see that sometimes rover will remain idle for quite some time and sometimes for multiple times at an attempt for a task. And it is really in those moments where those valuable lessons are learned and where very critical problem solving on the spot, troubleshooting, coordinating is taking place. Of course, these are times of high pressure, high stress levels. So the team needs to be able to work well together. They need to be able to coordinate together and manage those high levels of stress.
Absolutely, and as we saw yesterday, some teams did run into some problems and perhaps things that they couldn't have predicted about their system, and that's really the beauty of coming here and being able to drive the rover around on this track, is that you understand more about your rover than you could have imagined. This is a type of environment that is really hard to replicate without a facility like this.
And cutting back to AGH the Polish team here, AGH Rover Team, still attempting to extract some of that sample, completing the space resources task. They still have 26 minutes remaining, so plenty of time. And we've already seen an incredible effort from them so far. It seems they've successfully extracted some of that sample. Round of applause from the crowd here.
We're hearing some cheers over there from the team. Hopefully a good sign.
The rover is now heading back in the other direction.
Leaving those gorgeous tire tracks on the lunar surface. I'm sure you'll hear us talk plenty about tires today. We obsess over the different approaches that all of the teams have taken.
The different suspension designs, what's more suitable, 4 wheels or 3 wheels, 6 wheels.
Yeah. How big or small do you make your rover? They're all required to fit within a 1 meter cubed box, essentially.
And there is also a weight limit as well, depending on the task. Where for the post-landing task, for example, there's a cap at 50 kilograms. So every rover does get weighed before every task that it participates in.
And the teams often have to build multiple subsystems that can be interchanged for the different tasks. We talked about the complexity earlier about what these rovers are required to do, and more often than not, teams choose to swap out things like their robotic arm for a scooping mechanism or remove it entirely to decrease the weight and add a computer vision system. So all of those also count towards a cumulative weight.
AGH Rover Team seems that they've gone over to another component of their system, dropped that sample, and now they're back for more. Incredible demonstration of that end effector there.
Again, the finesse required by these operators in the base station, relying just on the few camera feeds that they have to judge that distance and the size of the container, battling against the reflectivity of the sand you can see there.
So close. Are they heading for another sample? Or are they strategizing something else? We've seen incredible action from the AGH Rover team this morning, completing the space resources task.
Back over at Project Scorpio, there are just 8 minutes remaining for their time in the post-landing task this morning.
The rover has already attained a set number of points, descending down the ramp, navigating around the lander, even attempting to make that first host connection over there, which I believe did get them some points, although it wasn't fully successfully connected, and then heading back around here to the processing plant.
That's right. If teams are able to just nudge the host connection, that will give them some precious points. Again, reiterating that the challenge is really about giving as much of it as a go as you can. Just being able to nudge it gets you some points, and it sets a benchmark as well for future years. If a team can nudge the hose connection one year, maybe they can pick it up the following year, and then maybe they can connect it to the lander, and it's all about that iteration in the design, so you're not completely going from scratch every single year. The rules stay mostly the same. There are some differences, but generally, the topics of each of these tasks remain the same, and that allows teams to start with the base and continue to improve and continue to develop those systems as they go through.
And looks like we have movement again from Project Scorpio, completing this the post-landing task here on pitch A. They still have just 6 minutes remaining in their time countdown.
We've seen some last-minute attempts yesterday. There's still plenty of time. You can get a lot done in 6 minutes here in the post-landing task. You can hear some of the lunar wildlife out here in sunny South Australia. Beautiful weather this week.
And once again, this is only the second day of the Australian Rover Challenge, a 4-day competition spanning from Thursday to Sunday. And while you've seen yesterday and today the post-landing and the space resources task, over the weekend you'll see the 2 other tasks, so completely different challenges that these teams will have to solve, where they'll be doing the excavation and construction task, and then the mapping and autonomous task as well on Saturday and Sunday. And the weather forecast looks like it won't be too bad on the weekend, a bit less warm than what we've seen yesterday and today. So hopefully we'll get more people coming out here in person. But we've had an incredible audience yesterday on the live stream, and we just can't wait to see what these rovers will get up to today as well.
Absolutely. For our online audience, keep those questions and comments coming through, and hopefully we can answer anything in our live stream as well. Top left there in that GUI, a really fascinating bird's eye view of their rover. Looks like they've stitched together multiple feeds to provide this top-down view. That's not something I've really seen yet from some of the teams.
Incredible interface work by Project Scorpio there.
Now what they might be going for now is the RFID reader. RFID being a form of near-field communication, like how ID tags work to gain access to buildings.
And that is one of the tasks to complete on the processing plant, is they must be able to tap that or approach that card there and read it, essentially collecting some very critical information.
They need to be able to download instructions that the rover then has to perform on the processing plant, hopefully fixing whatever might be wrong with it.
Incredible coordination and strategy by Project Scorpio, deciding in their final minutes of the post-landing task to attempt that RFID task here. And only 3 minutes remaining now.
Oh, this is fantastic. We've got inset there, AGH Space Systems. So we can see both rovers simultaneously completing their different tasks.
With just 2.5 minutes to go, a moment of suspense as Project Scorpio begins approaching that card reader.
And AGH still attempting to get some of that frozen regolith.
It's cutting it very, very close. Will we see a successful attempt at this task in an attempt to achieve some very precious points before the time runs out for Project Scorpio here at the post-landing task?
The deliberation there from the base station team. Just over 1 minute remaining. Are they going to have another crack at the hose connection?
Already we've seen an incredible effort from this team so far. Will they make a spontaneous dash of action with just 40 seconds remaining for the task? Or will they be calling it here for the post-landing task today?
This is Project Scorpio's last appearance on the rover field today before they come back tomorrow to compete in the mapping and autonomous task.
And that is all the time Project Scorpio has. Some cheer from the crowds there. Incredible effort for the post-landing task. Well done to the team.
Fantastic effort by Project Scorpio there. And with 15 minutes remaining for AGH, what is their next move going to be? We'll have Bluesat up on pitch A at 9:45 a.m. local time, so just 5 minutes away. Don't go anywhere because the next team will be attempting the post-landing task while we watch AGH Space Systems continue to persevere over on pitch B for the Space Resources task. Check out that camera view.
And Bluesat, which we are expecting to see here shortly in pitch A, is also another Polish team, isn't it, Georgia?
I believe so, and again, it's amazing to see more international teams joining every single year, and hopefully we'll continue to add countries that are participating in this challenge as well.
It seems we stand corrected. Bluesat is not one of the Polish teams here today for the Australian Rover Challenge. They're coming down here from the University of New South Wales.
Much closer to home. But again, still from around Australia. Adelaide Rover Team are the only team in the competition from the host state of South Australia and the host university, the University of Adelaide, which from next year will become Adelaide University. The rest of the teams have come from around the country, comprising almost every state and territory. Great view here of all of the systems on that AGH Rover. Many of the tyres here are 3D printed. May look like some sort of rubbery texture, but that's often a 3D printed filament, known as a thermoplastic. You can see there that the wheels on the bottom surface touching the lunar soil have deformed a bit. And that's really one of the huge advantages of 3D printing, is that you can change the material properties in the different axes. So you can have this deformability on the surface to gain traction and to move through that difficult regolith. But then the side profile, where you've got this intricate lattice, has the strength to be able to support the rest of the rover systems. Again, there is no air pressure inside any of these tyres. We're going for as realistic as we can get it. The moon doesn't have an atmosphere, so we wouldn't be able to have this type of system.
And there's that camera feed which the base station would be seeing right now as they operate. This is Team AGH Space Systems. Great coordination there in the base station, the mission control. With just about 10 minutes remaining for the space resources task, we've already seen some great action from this team with an attempt to scoop some of those samples. And they did successfully scoop one of the samples that I saw, and I'm not sure if they even did more than that as well.
The teams will get points for being able to successfully image all of the sides of frozen regoliths. So if they've been able to attempt that and get a sample from the site that they think contains the most amount of water content, then they'll be looking at some good points gained this morning. And again, even if they may not be entirely successful this morning, there is still the resources presentation that the team will be required to present afterwards. It's really connecting the practical system that they've designed with what they actually understand about the science behind what this rover is trying to gather. We spoke a bit yesterday about the interdisciplinary skills that are required to be part of a team like this, and the Space Resources task really reflects that. It's scientists and engineers working together, but also just as equally, many of these teams have social media managers and finance teams and business managers that allow them to get the finances needed and the support behind their sponsors to continue to compete in this challenge every year. All of the teams adhere to a cost cap of 35,000 Australian dollars, and that equalises the playing field.
We're still seeing AGH Rover Team or AGH Space Systems team attempting that space resources task. They still have 8 minutes remaining over on pitch A, we are still waiting on the next team to come and compete, which is Bluesat. Now, a reminder, their countdown does officially start at 9:45 a.m. local time. So the teams don't have to be on the pitch ready to go when the countdown starts. They are allowed to take as much time as they need to do those final critical system checks, troubleshooting to ensure the rover will be able to operate smoothly and to ensure that a successful connection has been established with the rover as well. But that time that they do take does eat into, if it takes longer than necessary, it would eat into their time or attempt time for the post-landing task. So we're seeing that there's 37 minutes on the countdown there. Still plenty of time, but hoping the Bluesat team will show up soon here on pitch A.
Oh, and that looks like some sort of processing system there.
We haven't seen this approach yesterday with the teams that have completed the Space Resources task. It seems that AGH Space Systems team has a separate unit for the processing that's sitting there on the pitch. I wonder if we can get a close-up of that. It seems to be operating, and that's where the rover seems to be picking up the samples and dropping it into or delivering it to. It's a very interesting, very different approach to what we've seen so far with the Space Resources task.
Yeah, so we can see their additional payload there. Payload meaning the device or piece of equipment that a rover might be carrying that enables it to undertake its mission. So potentially, we might have missed this earlier if they deployed that device on the surface from their rover.
I didn't really keep count. I don't know how many samples they've picked up and delivered already. So what an incredible effort. And even with just 6 minutes left to go, they've already achieved a good number of points.
Again, I think that's one of the really exciting things about the Rover Challenge is that every day we're seeing something surprising and new that many teams haven't attempted yet, and that's because the way that we are undertaking these missions is constantly evolving because it's right at the cutting edge. So the tech is moving as the teams are designing these rovers, and there's new developments in the electronics and the robotic components, and that only increases the bandwidth of what teams are able to achieve.
Absolutely. And we've talked a lot about the different design approaches that we see with each team, the different strategies, the different ideas, and the different ways they're taking on this challenge. And it just goes to say how important diversity is in a team, particularly in projects like this. You need people who come together to work on stuff like this where it needs complicated or complex systems, needs people from all different disciplines, all different backgrounds. You need to have that diversity to have all these different ideas and views. And that's where great ideas essentially are born, in a group of people working together that each contribute something different, something unique.
Absolutely, and going back again to this idea of heading towards sustained human presence on the lunar surface, space should be reflecting to society. If we're going to have humans out there establishing a lunar base or some kind of research station, we need all of these different backgrounds and perspectives. So there's a chance that if you've got an interest in space and perhaps it doesn't align entirely with engineering or science, there is absolutely a place for you.
And speaking on that, Georgia, we're actually seeing that change now with the Artemis program. So if you're not familiar with the Artemis program, it's a NASA's program through which we are sending humans back to the moon, but this time with a long-term goal to establish a long-term human presence there. And it's all part of the Moon to Mars initiative as well, which is getting to the moon first, building a base there, building that capability, and then heading to Mars, sending the first humans ever on another planet, and seeing all of the benefits that come from that, or the different exploration, the different discoveries that we can achieve from that. And part of NASA's Artemis program is they'll be sending the first woman and the first person of color on a lunar mission, which is pretty exciting. So we did have the Apollo program, but we haven't seen that diversity in the astronaut crews that were being sent to the moon back in the 60s. So this will be a very exciting time for humanity.
We're seeing AGH potentially returning back to their processing tool. Just under 3 minutes remaining. This is really the crunch time now. Can they get a large enough sample and be able to deposit it in that device? They're going to attempt it now.
And this is one of the teams that we've seen an incredible demonstration of that precise maneuverability, that degrees of freedom that we were talking about on the robotic arm there. Just extremely redundant and reliable systems. We've seen action all throughout their attempts so far. And while at the same time acknowledging that these are fully student design and built rovers. So while the other rovers may have setbacks, they may lose connection, it is all part of that experience. We are not expecting these rovers to be completely professional, 100% working all the time. It's really just about giving them that opportunity to come here, test their technology, demonstrate those skills that they build in their spare time alongside their studies.
And they're making a mad dash back. Just over a minute and a half remaining. This is it for AGH Space Systems.
Effort until the last second.
And tomorrow we'll see AGH return to the field again, this time to compete in the excavation and construction task over on pitch A. You can see the tension, those space station controllers there. Doing everything that they can to get the most performance out of their rover in the final minute of their task this morning.
Will they collect one final sample and deliver it to that processing plant? Or will they call it here? Incredible display of effort and determination in the entire 40 minutes they've had to complete the space resources task over at pitch B.
And we'll have the University of Wollongong out on pitch B at 10 o'clock a.m. local time. So in just 5 minutes, there'll be another team here on this track. If you're tuning in live, don't go anywhere. And that is time up for AGH Space Systems. Give them a round of applause. Fabulous effort this morning.
Incredible work to the team. There's that relief on the faces of the team members at the base station there. What a fantastic view of that rover there. The white is really coming out, very bold, very bright, optimistic vibes is what I'm getting.
Absolutely, it really calls back to some traditional rover designs that we've seen from the likes of Curiosity and Perseverance. That white and the sort of dusty brown of the tires. It's really amazing to see.
It's been incredible seeing yesterday and today as well, the different rover designs. We talked a little bit about that. The appearance is also an aspect to consider here. We've seen so many different rovers with bold, flashy colors. We've seen some with a very nice duotone theme. We've seen incredible different approaches to the antenna, to the drive system, to the robotic arm. One of them didn't even have a robotic arm. It had all its payloads attached to the chassis in one way or another, and it's just been incredible to see that diversity of design approaches.
Completely.
And just a reminder here on pitch A, we're still waiting on Bluesat, who have had their countdown started just about 11 minutes ago now.
Oh, there they are, over in the rover workshop, hard at work on finalising the remaining systems of their rover. And this is not uncommon too, especially for first or second time competitors. When you're having to transit your rover across borders and then sometimes rebuild the system when you get to this side, you want to be checking everything. And it looks like they had the multimeter out, potentially checking some of the connections between those wires. The stress is high, but this is really when the teams shine, is when they pull together in these moments and persevere through, get something out on the track if they can.
What an incredible effort we're seeing there from the team. The troubleshooting, the on-the-spot problem solving from Bluesat, over from the University of New South Wales.
And it can't be understated too that the electronics are one of the toughest components of these rovers. You've seen today that there are so many intricate subsystems that are all required to integrate together to a core system. Every single wire matters. We mentioned yesterday that, in my experience, sometimes a single pin falling out can result in the failure of an entire subsystem. And you're standing there on the field trying to find that pin and repairing it and getting the rover back up and running. It's an unbelievable feeling when you see it all power on, working after just minutes earlier thinking you were doomed.
It's an incredible experience, and we really do congratulate the teams just for being here, getting that rover built and operating, and coming out here from all over Australia and even from outside the country. And we acknowledge the difficulties faced with even having to travel, like Georgia was saying, with these components, and especially for the international teams. It must have been an interesting experience coming through Australian border security with all of these components for the rover.
Absolutely, and many of these rovers runs on huge lithium-ion or LiPo batteries, and that's another complexity in itself. Sometimes the teams have to collect the batteries when they get here to South Australia, so they have persevered and they've been able to solve problems with the logistics and arriving here, reassembling their rover and getting it out on the track. And I guess this is similar to some of the things we see in motorsports as well, where they're traveling around the world with these highly sensitive components, and understanding those logistics is only further preparing students for a real-life career in a field like the space industry.
We're still seeing some troubleshooting there. And this is the first time Bluesat will be coming out here and competing, isn't it, Georgia?
I believe so. 25 minutes remaining, that is still plenty of time. We've seen rovers before come out with just 10 minutes remaining and still having time to get precious points, descending down the lander and circumnavigating around. We love to see an Allen key set there, an essential tool set for any engineer. You'd be hard-pressed to find an Australian rover challenge that didn't have the emergence of duct tape. And it seems like we might have University of Wollongong coming out onto the field for the space resources task.
We've seen this team compete yesterday in the post-landing task, and what an incredible display that was, with the very innovative idea of having that second mini rover that they've nicknamed Roo. We're seeing the team utilize some very handy handles there they've attached to carry the rover across over to the space resources pitch.
Very scientific with the lab coat there too. Safety is paramount here in the competition as well. All members are required to wear safety glasses and ensure that they're, putting themselves first. And it seems like we've got Rue back out on the pitch again.
I can't wait to see what Rue will get up to today. Just a reminder, this is the University of Wollongong completing the Space Resources task. Their countdown has officially already started as of 10 a.m. local time, and the team is allowed to do any final systems checks and troubleshooting until they're ready to call it. Once they do, all communication between the field team and the base team will be cut off, and the rover will begin operation.
I'd love to get a close-up of that marsupial deployment if we can this morning. We missed that yesterday, and it looked like there might have been a comms issue or something similar with the rover, only to see a second rover appear. Base station team getting ready. Again, the Space Resources task requires a lot of strategizing from the base station team, carefully choosing the sites they prospect so that they can excavate one and process and figure out how much water is inside that sample. Using all of the knowledge that they've learned in the lead up to this challenge about volatiles on the lunar surface, how to even extract something like that, how to determine the water content, really showcasing what they know in the Space Resources presentation. Bluesat there, still hard at work, a commendable effort, still plenty of time remaining.
And I really can't wait. I hope we can see this rover in action and a close-up view of those components there. Some really nice blue colors coming out. And I think we've also got some teeth on that end effector on the robotic arm there. So an incredible bold design. There's a nice close-up there of the end effector.
It's great to see teams having a little bit of fun with their rover design. They seem to have a bit of a dinosaur theme going on. I believe it might be a stegosaurus. And if things don't work out this morning, Bluesat will have another attempt at a task on Sunday with the excavation and construction task. We see some flashing lights there. Still not over yet.
University of Wollongong still to initiate or begin operating their rover here on the second pitch to complete the Space Resources task. I really can't wait to see that mini rover over there deploy and start working. We're seeing what looks like a processing unit there on the rover. So once again, a reminder that these teams will have different subsystems or units that they can attach or detach from the rover or to the rover, depending on the task that they will be completing. So depending on what you need to do, you'll need different units or systems, and that's why the rover will be weighed before each task and before the rover goes onto the pitch.
And with the teams competing just once per day, that really reduces the burden on them as well, so that they have time after they've competed in a task to be able to change over their subsystems if they need to, do some tests, do those checks, and make sure that they're ready to go for the following day. The workshop here opens at 7 a.m. local time, and I would say all of the teams are here in some capacity, working on their rovers from the crack of dawn all the way through to sometimes 8 or 9 p.m. in the evening. The passion from these students is undeniable.
They should all be proud of themselves. We congratulate once again just for being able to come out here and compete. It's an incredible achievement.
And speaking of people here from dawn till dusk, our amazing technical committee for the Australian Rover Challenge and the competition organisers, and also many of our volunteer judges too, who have come from industry or our graduates from universities that have competed in this challenge. We thank you for your efforts. It's a phenomenal effort to put together a challenge like this, and it continues to extend its capacity year on year, making it an incredible and fun and enjoyable event for all of the students that come out here.
And there's some of our volunteers that make this event possible. Can we just get a round of applause for the volunteers, for the organisers, for the incredible team behind this incredible competition, running for the 5th time this year.
There are often long days here, out in the heat of the sun, making all of this happen. Now, yesterday we spoke a little bit about the communication systems that some of these rovers use, and Wi-Fi is not allowed in the competition. In real life, we don't have Wi-Fi yet on the lunar surface. It is something that will potentially be available in the future, but currently all communications happen over radio frequency, so we have exactly the same rules here for this challenge. All teams use RF communications of some sort. And unlike Wi-Fi, sometimes this can take a little bit to boot up. So potentially, if as a rover is stationary, it might just be establishing that first comms connection. That can take up to 5 minutes as well. I just noticed, Shagaf, but that is a huge antenna.
Oh, I did not see that. I think it was cutting out of the frame. That's incredibly large. Once again, just the different design approaches to completing these challenges, to getting these rovers operating, ready to go. We can see there at the base station for the University of Wollongong, incredible coordination amongst the team, just teamwork, problem solving. It must be stressful, but it is during these stressful times when the team really shines through, comes together and works together on the spot, which is not easy as well.
Potentially they're trying to get some extra range there with that antenna.
They might be trying to establish a connection, or they might be running with a different issue. We're not entirely sure. And we're still waiting on Bluesat, who still have some time remaining for their post-landing task. Oh, there we go. We have movement from University of Wollongong.
Fantastic stuff. Are they going to deploy Roo? We'll find out very shortly, I think.
I can see some duct tape there around that processing
You're
unit.
right.
Yeah, the very, very valuable tool for every engineer.
Our first appearance of duct tape on the track for this challenge. An essential tool for any student in the Australian Rover Challenge. Depositing of some material there for their processing payload.
The team is stepping away from the rover. It seems like that might be a good sign. Ready to go again. Will we see some action from both Kanga, the main rover, and Roo, the mini rover? Really loving the color scheme here as well. That silver on the metal, and then along with that hot pink, it seems, on the wheels, and those connections as well. And I love that both the main rover and the mini rover have that matching color scheme. Just incredible design effort. And there's the Bluesat team from University of New South Wales, who still have 13 minutes for their post-landing tasks, so still plenty of time if they can get that rover troubleshooted, operating, and on the pitch to attain some points for this task.
I don't know if we've got our roving camera around, but potentially we can have a look in the rover workshop and see the hive of activity that's happening behind the scenes of the pitches. We have a huge number of teams competing in this year's Rover Challenge. That means this activity in the workshop only continues to grow.
There we go. And it seems they've got some successful deployment.
There is a ROO on the ground.
Will we see it in action?
It's backing away.
Oh no, it's taking it with it.
There's the GUI there for the University of Wollongong. Looks like a different setup to yesterday.
Some reliable camera feeds there. Looks like ROO is on the go.
Talking again about the different feedback that teams can get from the systems. Seems like Wollongong are getting signal output and the velocity of their drive motors.
There we go, some action from ROO, that mini rover. I'm really excited to see how ROO can support Kanga in completing the space resources task. Just the different implications, the different benefits that having that secondary or second rover, a second set of wheels, one can say, roving around, cutting down on time to achieve some tasks, covering more space.
There it goes. ROO also has to apply to all of the same rules and regulations as the primary rover.
I don't think it'll have a problem with the weight limit.
You'll see it's got a huge emergency stop button on the back. Should something go wrong.
And a very small, adorable antenna sticking out there. And is that a small LED light at the back as well?
I believe it is. Again, another one of the requirements is having that LED light.
Simultaneous operation of both ROO and Kanga. Just incredible, incredible demonstration here from the University of Wollongong. Coordination from the team there in the base station.
Traveling alongside each other.
What an incredible view. Look at that.
Team of explorers. We spoke yesterday that this idea of having multiple small robots completing either the same task together or different tasks reporting back to a sort of hive mind rover is a whole field called swarm robotics. Hasn't yet been tested on the lunar surface, but is certainly a bubbling field. And to see an idea of this sort tested out here for the Rover Challenge is pretty exciting stuff.
And although it hasn't been tested on the lunar surface, we've definitely seen some applications here on Earth. And one of those is search, life, and rescue drones, where you can use swarm robots, in this case, for drones to go and fight against bushfires, look for people in need of help, people in danger, whether it be bushfires, whether it be even surf life-saving. There's a lot of incredible benefits to having small, modular, and reliable swarm robots that can go out, cover a large area efficiently, and do that for you. So here on Earth, we've seen the incredible benefits, which means there could be so many incredible implications and applications on the lunar surface in the context of space.
You bring up a really good point, Shagaf. We talked a little bit yesterday with Dr. Jason Armstrong about the spin-off and spin-in of space technology, and how the lunar surface is really an extension of some of the extreme environments we see here on Earth. We're talking about deserts and deep seas and places like Antarctica and really remote locations. And by designing for a place like the Moon, one of the nearest remote surfaces outside of Earth for us, it's really a test bed for developing robust, reliable technologies that we can then implement to help communities around the globe in remote regions, and even further do discovery in some of these environments like the deep oceans, much of yet we still don't actually know much about.
And once again, if you're just joining us, this is the Australian Rover Challenge Day 2. We've kicked off from about 9 a.m. this morning, and we've had a range of teams already completing both the post-landing task and the space resources task. And there's a nice view there of the teams hard at work in the workshop.
Testing some subsystems, potentially for a task later today that looks like URT from the University of Melbourne, checking out their robotic arm.
Look at that demonstration there. It's just incredible work.
Potentially even doing a bit of a practice run for the post-landing task later today. Using the precious few hours before they come on. They'll be on the track at 1:45 p.m. local time over on pitch A. So still plenty of time this morning to do testing and troubleshooting of that system.
Back on pitch P, we still have the University of Wollongong just almost at halfway through the space resources time. And we're still seeing some action on the field here from both the main and the mini rover. Will we see some successful analysis, some extraction possibly of the samples, and perhaps even some processing?
The teams will be required to image these sites and save the photos to provide to the judges afterwards. So the points will take a little bit longer to update for the space resources task. We might get them at the end of today, or potentially tomorrow we'll have that updated leaderboard showing.
Just a reminder as well, you can actually view the leaderboard as it gets updated live from your devices if you head to the Australian Rover Challenge website.
And that live leaderboard as well actually showcases a couple of different deliverables. You'll see the updated scores for the post-landing task and also something called a CDR and an SAR. Now, in the engineering design lifecycle, the CDR and the SAR are two critical milestones for any kind of project. CDR being a critical design review where teams demonstrate their complete rover design, talk about how they're going to achieve the design, and do their testing to be ready for the challenge. The system acceptance review usually happens towards the end of the project when you're ready to execute the mission and you're going through all of those different systems, confirming what you've completed, how you're going to mitigate any potential risks to your system, and it gets accepted. So teams submitted these deliverables and they scored points for those. And so all of those accumulations of points will be on the updated leaderboard.
And it really goes to show all of the effort, all of the hard work behind the scenes. Really, these teams have been working hard since the last competition, and some for even longer, for years and years of hard work, development, innovation, collaboration, and teamwork. It seems they seem to have somewhat of a lens attached there that they're positioning on that main rover over the samples to analyze the samples. We're seeing some action from the mini rover as well.
Now, I think RU's primary purpose for this mission is to act like a roving camera. It seems like it's got a camera attached on board, a tiny little robotic arm, which can position itself to see what the primary rover is prospecting. Amazing innovation there from the team, if that is what it's being used for.
Just giving you that external third party view or third point view of what your rover is doing, which is something we talked about a little earlier today, that the base station team that's operating the rover, once the task has been started, they can only see what they get from the rover from their communications. So just like what you see on the screen there, their live camera feeds and their sensors, that is all they have to work from. So if they are using that mini rover to get that external camera angle, that is an incredible point of view to have as well. We've seen as well with Project Scorpio was this morning, that had an innovative way of showing what their rover is doing, and they had multiple camera angles from the top stitched together almost to create almost a bird's eye view of the rover from the top. And they also had a digital twin, so kind of like on the software, on a simulation of exactly what the rover is doing live as it updates, which is just incredible.
Just amazing stuff. So they might be doing some analysis there. Over on pitch A, in just 7 minutes, we're going to have Deakin University setting up to complete the post-landing task. We can see them just outside the pitch, establishing what looks like their base station antenna. It's extremely important to make sure you've got the field of view there to be able to establish reliable communications with your rover as it traverses across the entire pitch. Sometimes, if that's not set up correctly, the rover can drop out as it goes behind some of the pieces of equipment on the surface or reaches into the far corners of the track. So it seems like they might be deliberating that at the moment, making sure that they've got that positioning correct. The last thing you want is a dropout. Great shot there from the University of Wollongong primary and secondary rover.
Incredible traction on those wheels there.
And it's interesting too to see how the design of those wheels is completely different to the primary rover. So they've really had to put some additional thought into this rover being smaller, potentially can get submerged in the regolith. Having those extra treads on the outside compared to the curvature of the primary kangaroo rover. You can see the tracks that it leaves behind there.
Now, while Bluesat may have had some setbacks this morning, unfortunately, they were not able to come out and have an attempt at the post-landing task. We will be seeing them tomorrow again for the other tasks that are happening over the weekend.
There's still more time to prepare those systems, diagnose what might be happening, get out the multimeter, have another crack.
In the meantime, it is 10:25, so in about 5 minutes, the countdown for Deakin University will begin, who have their Aurora rover set up. It looks like they're almost ready to go right on time on pitch A for the post-landing task. The team there looking optimistic, very exciting. We saw this rover in action yesterday for the Space Resources task, and now we're going to see them attempt the post-landing task.
We should mention too, the base station will be trying to set up in the meantime, and that's always a bit of a rush as well. I've been on the base station team before, and you're standing there in the side wings with your monitors and your laptops and Ethernet cables and power cables ready to go. And then you have to run in and set everything up in that precious time. It's about 5 minutes.
The University of Wollongong there, still hard at work, coordinating, strategizing for the Space Resources task. This is a task where we may not see as much action as we would in the post-landing task, and that's because part of the task is actually prospecting the samples. As you can see here, positioning them over the samples, positioning sensors or lenses or cameras. Part of this task is to actually analyze the samples and identify the one with the most valuable resource, and then potentially as well extract and process that resource to extract those valuable materials or minerals. So they still have 12 minutes, plenty of time completing that Space Resources task.
I saw a bit of a conical device deployed at the front of the rover before. I'm wondering if they've been able to do some prospecting with it. Saving some images there. It's a good sign that they've been able to capture a number of the sites.
Hard at work. Incredible effort by the University of Wollongong. Over at pitch A, we have our second team here coming up to prepare for the post-landing task. This is Deakin University with their Aurora rover that has a beautiful color scheme of black and orange. And those handles there, we talked yesterday about how beautifully clean this design and very neat it is. I'm interested to see how this rover would complete the post-landing task, given its very unique design approach.
This is Deakin Rover Team from Deakin University over in Victoria. Back to the University of Wollongong there. RU is potentially scoping out some of the other sites. Again, talking about the efficiency of these missions, they can use this smaller rover to save time to go to future sites that the primary rover will then traverse to once it's done its analysis. That will really cut down on the efforts by the team.
We're seeing that Deakin University has picked up their Aurora rover, and they may have headed back to troubleshoot or check something. Their countdown does begin in about a minute, so once again, reminder for this post-landing task, they have 40 minutes available to complete the task. Up to 100 points are available as well. So a series of tasks and activities, each allocated a set number of points.
Field team ready to go on the sidelines.
And their countdown has officially started. So they can take their time if they would like to do final systems checks, troubleshooting, if they need to troubleshoot to make sure the rover is operating, to make sure there's a successful connection between the base team and the rover. But it does eat into their task time. Once they're ready to go, they will call initiation.
So you'll see one of the members with the two-way radio chatting with the base station about how progress on both sides is going.
Probably having trouble hearing the base station team because we're talking too much.
Sorry. And the next team for the Space Resources task is getting lined up in the wings. That is UQ Space, who've just approached the side of the field, ready to dive in when it's their time. And that will be at 10:45 a.m. local time. So they're out bright and early, eager to get out on the pitch. For anyone who's just joined us here online this morning, you are watching day 2 of the 2025 Australian Rover Challenge here at the University of Adelaide Roseworthy campus in South Australia, Australia. It's a sunny day out here today, just as hot as yesterday, approaching 30 degrees as we get to the highest point of the day, just over 10:30 a.m. local time.
Weather hasn't been very bad this morning. The afternoon might bring in some higher temperatures, but the weekend is looking a bit better as well. So a reminder that this challenge is a 4-day competition. It goes from Thursday through to Sunday with a series of different tasks for the teams to complete. We have a range of teams from across Australia and outside the country as well coming down here to compete. This is the biggest number of teams we've had, and the competition only gets bigger and bigger since it started in 2021 with only 3 teams in the first competition.
So this is the 5th Australian Rover Challenge. And what a 5 years it has been. Just like you said, Shagaf, going from 3 teams to about 20 now. People just can't get enough of rovers.
It's a bunch of space nerds, if you ask me. All right, Deakin University is coming back out with their Aurora Rover. It seems they may have been able to troubleshoot and get things ready to go. We're hoping to see some action from the rover here. They have 36 minutes remaining, so only 4 minutes has been cut down. We're hoping to get started soon. Up on the ramp. And once again, the first set of points will be attained if the rover can successfully descend down the ramp and circumnavigate around that lander.
I tell you what, Shagaf, these team members will never have to do arm day again after carrying these rovers around the pitch.
Absolutely not.
50 kilos.
Sometimes up to
potentially.
90.
Exactly. And they have to be able to show to the judges that they've come up with a way to safely carry it as well. So that's why we see a lot of the rovers having those handles or detachable ropes to be able to carry it.
The team is walking away from their Aurora Rover, a good sign that we might see a beginning of an attempt at the post-landing task very, very soon. Descending down the ramp seems like a very simple task, but really requires some very careful movement and some careful thought into the design of the wheels and the weight distribution as well. We did see one case yesterday where unfortunately one of the rover teams almost tipped over trying to descend down that ramp. So that ramp that you see there, which is representing a ramp that real-life lunar rovers would descend down on the moon, it is only 1.6 meters wide, and there's a 20-degree decline there. So 5 points are awarded to the teams if they're able to descend down and all wheels are then in contact with the ground.
Getting the coordination between all of those drive motors on the rover can sometimes be trickier than it looks, and one of the teams yesterday, when they descended down that ramp, potentially the software wasn't quite doing what it was supposed to, and it essentially collapsed in on itself, which has happened before in previous challenges too. Again, a ramp like this is not something that's very easy to test, so sometimes teams are experiencing this decline for the very first time.
Back to the University of Wollongong here. We're still seeing some action on the second pitch for the Space Resources task, and they just have under 4 minutes remaining. And we're seeing some movement from Deakin University. Down the
Rolling
ramp.
down.
2 wheels, 4 to go. And that is all 6 wheels on the
Amazing.
ground.
Those first points awarded. Let's see where they go next. Now, sometimes you might see a pause when a team has done a drive forwards or backwards. Occasionally, they'll need to switch to a different system to rotate those drive motors for the rover to be able to turn. So if we see a pause, potentially that's what they're doing, or they might be assessing their surroundings using the camera feed.
We're seeing what the base station is seeing now. Their live camera feed, a rather different GUI or graphical user interface here to what we've seen with the other teams as well. Again, going back to the different approaches to solving all of these challenges. So many different aspects come together to make these rovers work. It's not just about the mechanical and mechatronic engineers. It's not just about people who are into robotics, but you have people who are specialized in material selection as well, people who specialize in software development, computer scientists to establish that connection, people who specialize in safety, like we were talking about before, with carrying the rover safely, weight distribution, the wiring, electronic and electrical engineers as well. There's so many different disciplines that come together, and as well as geotechnical sciences, as we have tasks here that represent having to extract those resources from the moon, having to analyze that requires that theoretical science of the geography, of the geotechnical side of things.
Got that rotation happening. Carefully surveying. This competition is not like other sports, where we're constantly seeing fast action on a field. Sometimes it's these careful, precise movements that end up being the successful way to get the most points. The teams also have to conserve these systems as well, remembering that these rovers have to survive 4 days of endurance. Many different types of challenges requiring sometimes the rovers being assembled and disassembled to swap over payloads. Keeping that suspension intact is a much more difficult challenge than it might appear. That suspension system there working really nicely as the rover goes over some varying terrain.
Incredible navigation of the terrain there. One of the biggest challenges of navigating real-life lunar rovers on the moon or on Mars, on any other surface that we're not familiar with, you can come into many different types of obstacles. So the design considerations there are extremely critical to ensure that these rovers can navigate through any type of terrain, through rocks, through any obstacles, and even connecting back to autonomy, which is extremely important to increase that efficiency of a rover. If it's fully autonomous, it can even incorporate systems where it can identify obstacles and rove around them with the use of AI or cameras and sensors.
If it approaches some difficult obstacles later, watch how the chassis stays level while the rest of the rover is at different heights trying to get over that obstacle. That is an invention from NASA, the rocket bogie differential suspension system used on some of the Mars rovers.
Incredible close-up view of the Aurora rover there. Some hot orange flashing from the wheels. A different design to what we've seen already as well.
And time is up for the University of Wollongong competing in the Space Resources task. Fantastic effort today, and we'll hopefully get those updated scores later today or early tomorrow to be able to understand just how well they did.
Incredible effort. Well done to the University of Wollongong. In just under 5 minutes, we're expecting UQ Space on that pitch over there to complete the Space Resources task.
Check out that movement there from Deakin University's rover, Aurora. The second rover, I believe, to be called Rover. Aurora.
Aurora, yeah.
Yeah.
Some of the rover names have been definitely interesting. Didn't the University of Adelaide have Egg at some point?
We did. We had Egg as our second rover.
What was the meaning behind? Where did that name come from?
Well, we had Lil Gaz in the first year, an affectionate name. And then the second year was Egg because we started completely from scratch. Again, the first year of the Australian Rover Challenge was a really interesting time because there weren't really rovers of this kind to even take inspiration from in the building of it. I remember sitting in a meeting and we literally looked at what NASA were doing on their Curiosity and their Perseverance rover. And at that time, Perseverance had only just landed down on the surface of Mars. So that's what we were going on. Now, as this competition has progressed, teams can take inspiration from other teams as a platform. I remember in the first year of the challenge, the inaugural champions, Monash Nova Rover, we learned so much from them. And they too had competed in the International University Rover Challenge. And they had learned from other teams. So this knowledge sharing is just, it cannot be understated how important this is to not just building the future of this challenge, but the future of the space workforce. It's directly influencing what is happening in the industry. And I don't think there are many competitions that could say that. It's just amazing.
It is quite incredible. And going back to what we were talking about, the sense of community that is built here, I mean, it is just really a crowd of space nerds, but also just everyone coming together, all these teams, the team spirit, the team culture that we're seeing, and the collaboration between teams and the support from the teams for the other teams has just been incredible, which just shows that determination, that passion, that community, and everyone is here to learn. Everyone is here for that purpose, to gain that valuable experience, to learn from each other, to support each other, and it's just been incredible so far.
So in just under a minute's time, we're going to have UQ Space out on the Space Resources pitch. If you've been watching us all morning, I'm going to say it again, don't go anywhere. We were only halfway through the teams this morning. Still plenty to come. Over on the post-landing pitch, after Deakin University, we will have Adelaide University at 11:15 a.m. local time, followed by QUT Raw. And after UQ Space on the post-landing pitch, we will have UTS with their Rocky Rover team.
That's the Space Resources pitch, Georgia.
Yes.
Yes, it is. We have UQ Space there, already ready to go. It is 10:45 a.m. local time, so the countdown does officially start now. And there is an overview of that Space Resources activities, each allocated a set number of points.
The iSpace Space Resources task, iSpace being one of the sponsors, industry partners of the Australian Rover Challenge. They're a company that is building a lunar lander. Their second mission is actually on their way to the moon right now, ready for touchdown in June.
And speaking of iSpace, we will actually be having an interview here at the commentator booth with someone from iSpace. And this will take place in just under an hour at around 11:40 a.m. local time. So do stay tuned for that.
Now we have Deakin University still making their way around the pitch, navigating that terrain. taking a look into some of the larger craters seen on this pitch. Clambering inside.
It's been fantastic effort from the Aurora rover so far, navigating around the terrain. It's potentially reading a status update at the moment. So one of the tasks involved with the post-landing task is that there are a number of screens around which display a status message. And the rover's job is to walk around using its camera live feed, identify these screens and read out the status message, which goes back to the quality of the cameras as well. They need to be able to read the status messages. The cameras don't just need to be good enough just to view the terrain and rove around.
So on the screen there, you'll see the base station team running some code. A lot of the teams use something called ROS, Robotic Operating System, that works via nodes to connect all of those subsystems together so it can send and receive commands sent by the base station controller. This is often something that students learn outside of their degrees because it's a very niche operating system for a general engineering degree. So it's an incredible effort by the teams to be able to learn this language.
Deakin University here at the base station, still operating the Aurora rover. They have 21 minutes remaining, almost at the halfway point, so still plenty of time. It seems they've already achieved a set number of points, reading out some of the status messages, already descending down the ramp and roving around. Will we see some more action from this rover if they approach the processing plant and attempt to make some physical interaction? Stay tuned to find out. Over at Pitch B, we already have movement.
Some excited cheers there from the crowd as UQ Space get underway with the Space Resources task. And for anyone watching yesterday, you'll notice that this rover looks different again as it did yesterday. The team have fitted a new payload on the front, presumably to complete all of the challenges in this task with prospecting, extracting and processing that frozen regolith sample.
Really excited to see the demonstration of that system there from UQ Space. Incredible traction, getting around the terrain, approaching one of the samples now. 35 minutes remaining. They've started with only a few minutes into the countdown, so incredible start already. There's that base station or mission control team operating the rover remotely.
4 camera feeds there.
Incredible views all around.
Well placed to see exactly what their rover is currently doing.
That is incredible placement as well, I must say.
We were saying earlier again, the judgment of the depth from the rover down to the sample is trickier than it looks. And it looks like they've got it perfectly flush with the sample. And if we get a chance to take our cameras back to the rover workshop, we'll hopefully be able to see some of the other teams setting up for the tasks that are still to come. We'll be breaking at about 12:45 p.m. local time here, so there's still just under 2 hours left of action out here on these pitches.
Deakin University Aurora rover has around 19 minutes remaining. Still plenty of time to see some action here at pitch A for the post-landing task. And you can see at the bottom right corner of the screen there, simultaneously we have the other team on the Space Resources task, UQ Space. We've said before, the Space Resources task tends to be a bit less physical action, because it involves more analysis of the samples.
Looks like an intervention has been called there by Deakin.
So once again, reminder, the teams can call an intervention if necessary, if the rover needs help and they need to intervene to get it repositioned, or to get it reestablish a connection, or troubleshoot any problems they are facing. An intervention does deduct marks from the points that they receive, but sometimes it is a necessary step, a necessary decision to make. In certain cases, they are allowed to call multiple interventions as well. And as you can see here, the field crew and the base crew have two-way communication while the intervention is going on. It will be cut off again once the attempt does resume.
See some activity back there from UWA inside the core of the rover. They will be preparing for the Space Resources task. They're due to compete at 3:30 p.m. local time later on today. Just like a garage, those rovers are being pulled apart and rewired at a breakneck pace, so they can prepare for the different challenges.
Seems UQ Space is finished sampling or analyzing one of the samples and has approached another sample. But hopefully they'll get some valuable information from their instruments and sensors there. Once again, this Space Resources task isn't just everything you see on the pitch today. As soon as the task is concluded, the teams will be required to give a presentation to a team of judges. It's incredible. You can see what looks like a thermometer there on that UQ Space.
Yeah, I was wondering what
effector.
that was all about.
It might have to do with some processing that they want to do in that unit, monitoring the temperature, but it could be also for safety reasons. But that's an incredible idea. And I'm wondering if they will be able to demonstrate some processing on the rover today.
Oh.
Seems like the rover's done analyzing that sample.
Potentially that was a bit of a shield for whatever camera they might have been using to image it. The intricacy of these designs, what to do on board the rover, it's just incredible. And delivering all of these systems, particularly for first-time teams, many of them have a development life cycle of just 10 to 11 months, sometimes even less. It's in contrast to real-life space missions, which often take years to deliver less of these systems. We see some movement there from the Deakin University rover. Have they got it back online? Just under 14 minutes remaining. Still able to make the most. potentially that intervention might help. Turning. It seems like we've got movement again. Re-establish comms. You can see here the benefit of that intervention, having their core systems back online, giving the task another shot.
It seems they're positioning their cameras to get a view, and it seems like they're saving an image of that status message as well.
We've got the thumbs up from the judges. They have successfully read the message on that side. Well done to Deakin University, getting some all-important points there. Despite that setback, they are persevering on, just like we've seen every single team do throughout this challenge. They are never giving up. They're so passionate about the rover that they have built, and they are not going to let it stop. Clambering out of that crater.
Incredible display and demonstration of those wheels.
Gonna try it again, perhaps.
That's incredible traction over the
Amazing.
crater.
Try and try again.
Fantastic effort.
Emerging victorious from that crater onto the next site.
They seem to be heading to the processing plant.
Amazing look at that suspension
Look at that
system
demonstration.
there. So smoothly getting over that rocket, keeping that chassis level.
Very, very bold movements. And demonstration of what Georgia was talking about with that suspension system. We're seeing the wheels go up and down, but the chassis remaining level. The rover seems to be venturing far beyond than any other rover we've seen in the post-landing task.
It potentially has a mind of its own at the moment. If it goes outside the pitch, they might need to grab it with the E-stop. Up, and there is our first E-stop of the challenge, a common occurrence.
Round of applause for Deakin University. Well done.
Absolutely incredible.
Such a fantastic demonstration. We're not sure what happened there at the end.
Usually this happens when you get a communications dropout. The robotic operating system, you send a command like drive forward X amount of steps, and it'll do that. And if your communications drops out, that's the last command that it's heard, so it's going to keep doing that until it has manual intervention like we've just seen there. So pretty common occurrence, and a great effort by the team there.
And a great example of the safety measures and precautions that are being taken here. So all teams are required to have an emergency or e-stop button on their rover in situations like these or other emergency or safety cases where the e-stop will need to be pushed to stop the rover and all systems on the rover.
Now, we were getting word from Mission Control that there is apparently an updated leaderboard, so we will hopefully be able to bring that to you soon and recap just where the teams are placed so far.
Over at pitch B, we still have UQ Space attempting their...
Here's our leaderboard.
There we go.
AGH. Oh, look at that points gap. Just 3 points between first and second place. UQ Space and AGH neck and neck at the moment. Monash Nova Rover in third, followed by University of Wollongong and RMIT. 4 Aussie teams rounding out the top 5. Just a handful of points in between them.
That's a very tight leaderboard. Once again, mentioning that this is not fully updated from all the tasks that have taken place so far since the beginning of the competition, particularly the space resources task. Once all the teams have completed that at the end of today, it will be weighed and evaluated and then accumulated into the leaderboard. So stay tuned for either end of day today or early morning at the beginning of day 3 of the Australian Rover Challenge. There will be a better updated leaderboard as well. So don't go anywhere.
Exciting times for AGH, but there are still plenty of tasks to go. There are 100 points available for each of these tasks. And they're all very different too, requiring incredibly different skill sets from the team. So you never know quite just what's going to happen over the next few days. This scoreboard could change at any time.
Now, UQ Space is almost at their halfway point, so still plenty of time, and they've already achieved so much in the 20 minutes, almost 20 minutes that they've been completing the space resources task. We've seen them utilize that shielded black material there, which looks like it might either be a sensor or a camera, some sort of instrument to analyze the samples, but now we're seeing them use a different system that they've placed onto one of the samples. And I'm wondering if that's some sort of extraction system or processing system, or if they're doing further analysis at this point.
Yeah, I'd be really interested to know if this was some kind of onboard mass spectrometer to be able to determine the content of frozen water inside that regolith. Or maybe it's an extraction core. Can see a linear actuator on the back there. Bit of a drill system, maybe. I'm sure all will be revealed quite soon if we see material extracted from that sample once it's moved away.
We're seeing some screenshots take place here, all for the presentation, potentially, that's required by the teams to present at the end of the space resources task.
It's clear that that thermometer on the side is important to this system, potentially giving an indication if the frozen regolith has melted enough to be able to extract it.
I think we're seeing a demonstration of that thermometer come into play here. It looks like the temperature has increased, and it might be some sort of processing unit on board that end effector or on board that rover here.
In the meantime, pitch A is being reset. In just 10 minutes, Adelaide Rover Team will be on the pitch. We can see them preparing on the side of the field over there. The rover Romulus will be making its second appearance for the challenge after they completed the space resources task yesterday. That's Romulus there. And the Adelaide Rover Team, the only South Australian team in this competition.
They look like they're set up, almost ready to go, right on time, as soon as their attempt kicks off at 11:15 a.m. local time. This is the Adelaide Rover Team from the University of Adelaide.
Checking back in there on UQ Space. This might be a good time while we're waiting, Shagav. I might go for a bit of a walk. Gonna go check out the back 10. See what's happening.
This might be a good opportunity, Georgia, if you can, to chat to some of the team members, see how they're going.
We'll see where this goes. This could be a grave mistake.
There's a view of that base station just earlier, hard at work. We said it's moments like these where essential coordination, teamwork, planning, strategizing is coming into play. The teams really do shine in moments of difficulty and hard work.
So I have made my way around the pitch into the rover workshop. We are here behind the scenes now, looking at all of the different teams, and wow, this is the hub of. We have the UWA Rover Team over here. How's it going, guys? Don't mind me intervening here. Rover have a name?
Is it? Percy.
Okay. Mythology, or do you just like the name?
A little bit of Greek mythology. It's actually our generation rover. So our first one was called Artemis. So we wanted to kind of follow that naming convention. And this one was obviously picked Perseus.
Love that. And you also had a miniature rover last year as well, I heard. Is that true?
Yes. Yeah, we had a miniature rover called Talaria. But that one was thrown out the window because it was in the too hard basket. Yeah.
It makes a lot of sense. It's a lot of effort, I can imagine, to try and have those two systems working together. That is awesome. So are you competing in the space resources task or post-landing?
Post-landing task, yeah.
How are we feeling about it? I know you're probably swapping over some payloads, something like that.
Yeah, we're feeling quite confident. A lot of last-minute duct taping, but other than that, it's pretty good.
That's what we want to see, right? We want to see as much duct tape as possible. I haven't seen enough of it so far, so I'm so excited for that. And lots of zip ties as well. Get it all out there, honestly. We have Shagaf as well. She's coming over.
What an incredible view we have here.
We're going to keep walking around. Thanks so much, everybody. That is QUT Raw. We've seen a bit of UWA over here. Who else can we find? Who else can we pick on over here?
The atmosphere here is just fantastic, I must say,
We have the Australian
Georgia.
Space Agency, everybody. Give us a wave.
One of our industry partners and sponsors of the Australian Rover Challenge.
So exciting. We have Caterpillar here as well, one of our other primary sponsors.
This is a reminder to come down here and visit these booths. We've got so many of these partners, sponsors, industry people who you can come here, chat to, talk to about space jobs. We've talked a lot about the space industry. We've talked about Australia's involvement with NASA's Artemis program, the first Australian lunar rover that's going to the moon. This is a great opportunity to come down here, not only see the teams that are hard at work, but also to these amazing industry people who have taken time out of the day to come out here for the Rover Challenge.
Absolutely, and we'll have members from the Australian Space Discovery Centre here on the weekend too. They love talking about space careers. Just come up and ask them. If you have a passion for space, if you have a job that you're thinking of, I bet you that we can put space in front of it and find a career for you. So come and chat to them on the weekend. I can see we have Boeing over here as well, another one of our generous sponsors. So please, if you're a student that's really keen about learning about how you can find your place in space, come into the tent and chat to these amazing companies.
Boeing is also actually the sponsor for one of the tasks for the Australian Rover Challenge, which is the mapping and autonomous task. And this task will take place over the weekend. So tune in on Saturday and Sunday. You'll see very different challenges that these rover teams will have to accomplish, other than the post-landing and the space resources, which is the mapping and autonomous and the excavation and construction as well. Let's go around and do a loop here and see what else we've got here. So all the teams, Bluesat in the corner there, hopefully troubleshooting the rover. We haven't seen Bluesat's rover demonstrated just as of yet, but we're really, really excited to see it being demonstrated. There's still plenty of opportunity. It's only the second day here at the Australian Rover Challenge. The vibes are really high. The atmosphere is
check
buzzing.
this out. Can you believe it? All of these teams traveling from around Australia and overseas as well from Poland. They are hard at work. When we say that they have long days, these are passionate students and they are not giving up.
What a fantastic view. We'll come around here as well. We have Monash Nova Rover on the right-hand side. This team has been one of the core teams of this competition, participating since the first iteration in 2021.
So, what's your name?
Kelly.
I'm here with Kelly today from the Monash Nova Rover team. Kelly, how are you feeling? You guys competed in the post-landing task yesterday. How are you feeling about space resources today?
I'm feeling good. I mean, at this point, it's sort of just up to the science leads. There's not really anything that's in our control. So, we just hope for the best. And we've worked really hard over the design cycles. So, whatever the outcome we get, I think we'll be happy with it.
That's a great attitude to have. And this is your first time competing Monash Rover for both? Second time, third time, fourth time? Tell me.
Yeah, so I've been competing since 2022.
You're a veteran of the sport. How about yourself?
Yeah, 2023, and that's when we actually started our Pink Rover initiative as well, so it was a big year for us.
Amazing. I can see your Pink Rover. Do you want to tell me a little bit about the Pink Rover initiative? I've heard about it, especially we and Beck were here in the Rover team as well.
Yeah, of course. So we made the Rover pink. The main message we want to just put forward is that we want STEM to be a space where people can openly express themselves. So we thought that just painting the rover a really bright color like pink is going to spark a lot of conversations. We want people to ask questions like, why did you paint a rover pink? And then, we could sort of just talk about, well, why not? Why don't we see the color pink in STEM? And so that sort of conversation helps inspire change within the industry.
Well, it certainly got us talking, and you're so right that diversity in STEM is so important to see as many different perspectives and backgrounds as possible. Space should be reflecting society, and if we can get that happening, if we can even showcase it here on the pitch, how amazing is that going to be for the future of the industry,
We've already seen it make a difference in our outreach programs as well. So when we go out to schools and we go out to the public, we have all these little kids coming up to us asking about the Pink Rover campaign, and it's just been a blast, yeah.
Just fantastic, and hopefully we continue to see a lot of younger here on the weekend when they come with their families, and hopefully you can continue to do some inspiration. Can I ask too, what are you both studying at uni?
So I'm studying at the Bachelor of Engineering, and we're specialising in mechatronics. Yeah, absolutely. But our whole team, we study a range of things from commerce, science, IT, anything really.
Because that backs up a lot about what Shagaf and I have been saying this morning, that this is such an interdisciplinary challenge, and it takes multiple disciplines to make this team work. Would you agree with that?
Yeah, absolutely. We need as many diverse skills as possible, and we can really get that from people who are studying different degrees.
There you go, you heard it here first. Diverse skills are the key to making a challenge like this work, and I think that's the perfect interview to wrap things up here in the workshop as we go back out. Adelaide Rover team coming out onto the pitch to complete the post-landing challenge in just under a minute's time. So we're going to make our way back, and thanks for joining us behind the scenes. Thank you to Monash Nova Rover, all the teams that we ad hoc interviewed this morning. We're going to cut back around. I believe Shagaf might have gone back to the desk. She can cover all of the action happening on the field over there.
Back on the pitches here outside of the Roseworthy campus, the University of Adelaide Roseworthy campus. UQ Space is still on the pitch completing the space resources task. We've seen some incredible effort from them, going from sample to sample, utilizing their different systems and instruments to analyze those samples and hopefully extract. We haven't seen any scooping mechanism. They seem to be going with a different approach or different strategy, and they still have about 8 minutes remaining to complete this task. Don't go anywhere. Once UQ Space is done with this task, we'll be expecting UTS, the University of Technology Sydney, at 11:30 a.m. local time. Over on pitch A, we have the Adelaide Rover Team from the University of Adelaide. They seem to have set up and ready to go. Their countdown does officially start, or has started officially as of 1 minute ago. They seem to be waiting for that call for the team to officially initiate the task and step away from the rover. And you can see this the countdown there, 37 minutes remaining. Just kicked off the post-landing task for the Adelaide Rover Team. This is their rover Romulus, who is situated on that lander, ready to complete the post-landing task as soon as the team has ensured the rover is all checked, systems are go, and that there are no issues that might affect the operation of the rover. And establishing a connection here is one of the core, most critical things as well. There's the base station for the Adelaide Rover Team, hard at work, communicating with the field team, troubleshooting, problem solving, incredible effort and coordination, just like we've seen from every other rover team as well. Once again, 6 minutes remaining for UQ Space. The base station hard at work, coordinating. Decision making is a critical skill, a critical task that the team will need to be able to cooperate and make decisions on the spot, but at the same time, not rush to make the decisions and carefully strategize, carefully plan out these sorts of scenarios. There are some things that these teams might face that they haven't faced before when they were testing and developing. And so it really is a highly stressful task. It's a highly stressful environment, but it's an incredible achievement, some valuable experience, a great 4 days for this competition. We already had the first day yesterday, and we're almost halfway through day 2 of the Australian Rover Challenge, with the next 2 days bringing on some new and interesting challenges as these teams take on the excavation and construction task and the mapping and autonomous task as well. And there's that Adelaide University, the University of Adelaide Rover Team. We're waiting on some action from the rover. The team has stepped away, a good sign indicating that they could be ready to go to complete the post-landing task. Nice view of the Adelaide Rover Team, rover Romulus, sitting on the lander. a quite unique suspension design, some incredible wheel design there as well. A lot of coordination happening. Oh, there we go. We can see some action. The wheels have adjusted themselves. Will the rover be taking its very first tread soon? Here we go. Movement from the Adelaide Rover Team. Carefully and quite boldly down the ramp. All 4 wheels in contact with the ground. And that achieves them their first set of points. We're seeing incredible demonstration of that wheel drive system. Incredible maneuverability on the spot, turning that rover.
Wow, what did I miss, Shagav?
We've got the Adelaide Rover Team here. They've kicked off, descended down the ramp. We're seeing some incredible displays of the wheel maneuverability here. And looks like they're heading towards the back of the lander now.
The snap lock of that drive system. Now the team has a completely different wheel design this year too. The last few years they opted to go with the same design and they've completely shaken it up this time. This will be a fantastic test of that new system. And I've heard a completely new rover as well. Hopefully this will be the foundation to go forward for future years. It's very exciting stuff.
We're seeing incredible transversing across that terrain.
We spoke about with some of the other teams, a few of them have this ability to turn what we call turn on a dime. So it can turn around itself, just as we're seeing here. Check that out. And that really minimizes the space required to move forwards and backwards and rotate around, allowing you to be as efficient as possible getting from point A to point B. The base station team looking intensely there. You would have noticed this morning that many of these teams are using gaming controllers to be able to control their rover. A far cry from what we used to see, even just a decade ago, where everything was command line, typing in these things on a keyboard.
Incredible user interface there. Multiple camera feeds for the Adelaide Rover Team as they make their approach towards the back of the lunar lander to complete one of the activities for the post-landing task. They have 30 minutes remaining, so plenty of time, plenty of opportunity. Look at that display of all the stickers.
The speed at which this rover can rotate around.
Quite incredible, really. Beautiful color for the wheels as well.
And those are 3D printed from TPU. Thermoplastic polyurethane gives this incredible rubber tire-like texture to the wheels. Not plastic. You can see the intricate structure there, how it deforms.
Over to pitch B, UQ Space has now officially concluded their space resources task. A round of applause for the team. Incredible effort. With 40 minutes up, it seems like they might have successfully extracted or even processed some of that sample, which I think is an indication from what we saw before with that thermometer, the temperature going up.
You can see the way they're carefully handling it there. It's likely extremely hot if it's been trying to melt a frozen sample. The moment of reveal here. Again, safety is paramount in this competition. The suspense. Undoing that.
What an incredible effort from UQ Space here.
Oh, it looks like they were drilling in with that cutting edge, which must have been collecting the samples at the same time.
This is the first team we've seen so far of visual confirmation of a potential successful extraction and even processing of that sample. Don't go anywhere though. In just a few minutes, University of Technology Sydney will be on pitch B to complete the space resources task.
And that is 11:30 a.m. local time. The last team this morning to compete in the space resources task.
Before the lunch break.
Can't wait for that.
Over back to pitch A. The Adelaide Rover team is roving around the pitch, making its way all over the field to accumulate some points for the post-landing task.
Like Monash, Nova Rover and RMIT, Adelaide Rover Team was also part of that first trio back in the first Australian Rover Challenge in 2021. And they have competed in every Rover Challenge since. A different rover for every challenge, trialling and testing new subsystems, new design philosophies. They're confident with this design that they've settled on a foundation that they can build on, take them into future years. Looks
There's
like
an incredible view of the rover. From a bird's eye point of view as it makes its way around.
potentially trying to avoid going directly into the crater. Perhaps they're just getting a bit of a feel.
Beautiful demonstration of that maneuverability on the dime rotation, like Georgia was describing earlier.
The team was mentioning earlier that this is the first time they've had a four-wheeled rover as well. Every other year they've gone for a six-wheeled system. This is a diversion away from previous designs.
The wheels on this rover have really been shining through, demonstrating their capability, the maneuverability that they give to that rover, and even effectively moving fast, cutting down time for moving around, transversing across the terrain. Just incredible work. I want to see the other systems on this rover interplay as well, particularly the robotic arm.
A whopping 5 camera feeds operating simultaneously there. Oh, it looks like they might have found something. Can they get close enough to read what might be a message? Looks like a fellow broken down rover. Rovers repairing rovers. Oh. Is that the robotic arm? It is. The robotic arm is being deployed from the rover chassis.
Incredible
Oh, this is
display.
just, look at that. They might reach into the crater to read the message, perhaps. What a use of that arm that would be. Saving the time and effort to descend into the crater, making use of those subsystems.
It's a mighty demonstration. Incredible.
Leaning in.
reaching out.
The careful balance between going too far, being able to still retract. Can they read it? We'll wait to hear from the judges, who should give us a thumbs up if they have succeeded.
Seems on the camera feed there, they've extended the arm to get closer, but the message is now out of the view. They may need to angle that camera if they can, which just goes back when we were talking about degrees of freedom, maneuverability for the robotic arm, and having those joints to have that degree of freedom, those degrees of freedom.
Are they going to go into the crater? Meanwhile, on the other pitch, UTS are beginning to set up their rover.
We have the Space Resources task on the other pitch. We're expecting UTS to give some action soon, as their countdown has started about 3 minutes ago at 11:30 a.m. local time. With 40 minutes available to complete the Space Resources task, there's up to 100 points available, and this task is sponsored by iSpace.
They'll be joining us for an interview soon, actually.
Yes, they will. So we will be having an interview here shortly with someone from iSpace in just under 10 minutes.
We'll be joined by Miss Hiroko Asakura, Global Alliance Specialist at iSpace. We look forward to asking her some questions when she joins us at 11:40 a.m. local time. Adelaide's still making good use of their robotic arm there. Looks like it's also made from some carbon fiber links, hopefully reducing the weight of the system, but giving it enough strength. Some strategizing there from the base station team and mission control. So we wait to see what Adelaide's next move might be. Switching back over to the other pitch, it looks like UTS is off and running for the Space Resources task. Making its first movements on that pitch. Nice close-up shot there. They too have another payload attached to the front. Ooh. What's happening here? Oh my gosh. Spring-loaded suspension perhaps.
This is something we haven't seen before.
Again, we just keep getting surprised by the designs of all of these rovers.
That's incredible, that ability to move that chassis up and down.
I want to see that again. That was amazing. Thanks. I wonder if that will get the rover closer to the samples, perhaps, rather than having the payload extend down. Maybe the whole rover will
Once
get
again,
closer.
very different design approaches to doing things.
Be so interested to know. It looks like there are some linear actuators on the side, potentially providing that maneuverable suspension there.
And there's that camera live feed. Once again, this is University of Technology Sydney, completing the space resources task. This is so UTS Rock-E Rover. Rock-E the rover is what the name is here. And they've just started not too long ago, so they've still got plenty of time to complete that task. And here we have an overview of what this task is comprised of. It's sponsored by iSpace. We will be having someone in just about 3 minutes joining us from iSpace, actually, who will be here for a quick interview. So stay tuned for that.
Base station team there looking pretty cool, calm and collected. Hopefully a sign of good things to come. It's a reminder too, as one of the team members is drinking water, the sun is starting to come out now here down at the Roseworthy campus. Make sure you're staying hydrated. Top up on some water if you haven't already. 6 shades, slide on sunnies, and wear that all-important sunscreen. The UV levels are high over this weekend. As UTS considers their next moves, the Adelaide Rover Team has come away from that crater and travelling to another site, perhaps.
With 15 minutes remaining for the Adelaide Rover Team to complete their post-landing task, they will need to be looking at strategies to get as many points as they possibly can in their remaining time. And while we have activity happening here on both pitches with the Adelaide Rover Team and UTS, on the Space Resources pitch, we're going to do an interview here. We're joined by Miss Hiroko Asakura, who's here from iSpace, actually. Thank you so much for taking the time to do this interview with us here at the Australian Rover Challenge 2025. It's been an incredible view so far today, and fantastic to have you here join us. And you've been a supporter of the competition since it first began, which is incredible. First question that I have for you is, how do you think competitions like this one prepare the students for joining the space industry?
Thank you for having me today. And yes, I'm really excited to see the teams and students are doing a great job, and they have their own strategy and their own methods to overcome the challenge. And I think it's an excellent opportunity for them to gain their project management skill or the team management skill. So as an iSpace, we have over 300 colleagues here from over 30 nationalities, and some of them are from Australia. So we respect each other towards our mutual goal for the moon. So yes, I think this challenge will help the students and the team to pave the way for their careers.
Absolutely, that does sound exciting. One really incredible thing about iSpace that I will actually promote here, not many people might know, is that you have your M2 mission, which is the Resilience Lander, and that's on its way to the moon right now as we speak, which is pretty exciting. So could you tell the audience a little bit about the mission and how it's going?
Sure. So we have launched our M2 mission in January this year, and now we are on the way to the moon, and landing date will be on June 6th. And yeah, we are doing very well in the condition. And yes, we are carrying many payloads on board from our customers, and including deep space radiation probe from National Central University of Taiwan, and water electrolyzer from Japanese company Takasago Thermal Engineering, and so on. So one of our most important missions in M2 in iSpace is to deliver their customers' payload very safely to the moon surface.
Yeah, absolutely, which can be a very big challenge, as we've seen demonstrated here at the challenge, but also in general, the fact that your mission is going well is an incredible achievement already, even though it hasn't reached its destination. It's such an incredible achievement. We've seen the challenges that we can face in terms of spacecrafts and space systems, particularly with communication as well. So if you've got communication going and you can talk to your spacecraft and it's heading to the moon on its way, that's incredible news. But on the topic of rovers here, we're at the Australian Rover Challenge. Resilience, your mission, is carrying iSpace's very own tenacious micro rover. When is that deployed on the lunar surface? What will its mission be?
Yes, speaking about the rover, so we will encounter the interesting geologic features on the moon, and we will drive on the moon surface, and with a scoop developed by Swedish mining company called Epiroc, so to scoop the lunar regolith. So, well, finding the lunar regolith and understanding the future of the moon surface is important, not only to help us to understand the lunar surface, but also to help us to develop our future rovers and also the future technology for the Institute resource utilization.
Yeah, absolutely. And that really connects back to what we've talked a lot here about establishing a long-term human presence on the moon. And we've talked a little bit about Australia's first lunar rover, Rover, which is heading to the moon with one of NASA's Artemis missions in the next 5 to 10 years. And that will also have a purpose of extracting some lunar regolith, and it's trying to extract some valuable resources from that lunar regolith. So there seems to be a very big interest in what we've talked about, Georgia and I, which is ISRU, Institute Resource Utilization, which is the concept that going to your destination and having where you are the resources that you need and being able to extract them and use them. Very valuable things here. And just as a last thing, do you have any final words of encouragement to all the teams that have come out here today, tackling some of the most challenges, difficult challenges, but also some of the same challenges that you and iSpace might be tackling and addressing with your lunar mission?
Yes, I would like to repeat my words. Your team, every team is doing incredible job, and yes, I really hope that in the near future that iSpace can carry their flight models to the moon.
That's fantastic. Well, thank you so much for coming on here with us today. Thank you for your time. And we'll hope to see you around. I've seen you around walking, looking at how the rovers are doing. And yeah, so thank you for coming on, and we'll see you around.
Thank you so much.
Thank you.
So that was Miss Hiroko Asakura, Global Alliance Specialist. at iSpace, one of the sponsors of the Space Resources task that we've seen here over the last 2 days. Thank you so much for joining us. Back to the pitches now. We've got Adelaide Rover Team still out there on the track. 8.5 minutes left to go. Potentially an intervention has been called here.
Once again, an intervention can be called if the teams need to intervene to potentially reposition the rover or troubleshoot to get it back up and going. And that's exactly what we're seeing demonstrated here. According to the rules, the teams are allowed to call multiple interventions, but it does deduct, each intervention does deduct multiple or a penalty from the marks that they achieve. Sometimes an intervention is a necessary decision, as we've seen demonstrated here over the past day and a half at the Australian Rover Challenge.
So they are repositioning that rover, which is allowed.
There's some repositioning in front of the processing plant. Will we see some action from the Adelaide Rover team to complete some of those tasks associated with the processing plant?
You can see they're chatting to the base station crew there.
Communication between the teams is allowed during the intervention, but once the intervention is complete, they will not be allowed to have two-way communication at all. Over on pitch B, we still have UTS, University of Technology Sydney, attempting the space resources task almost at their halfway point. Plenty of time to attain points. And if you're just joining us, this is the Australian Rover Challenge, the 5th installment of the competition here at the University of Adelaide, Roseworthy campus. I'm Shagaf, joined by Georgia. We're your commentators for today. And we're here in South Australia, Roseworthy, where the sun is out and bright, giving us a high of 31, 32 degrees, quite a warm day. Once again, we do encourage sunscreen, hydration, and some hats as well, particularly for our volunteers, the camera crew, everyone that's working out on the field to stay hydrated and stay safe.
UTS absolutely zooming along on that lunar terrain. You could almost call that a dune buggy. Shredding through the lunar regolith. Where are they going to go next? Oh, an Adelaide Rover team attempting to use their robotic arm again. UTS continually driving around on that surface. That is amazing.
They've covered a mass area here.
I know we said there was less action on the space resources task, but wow, that is a lot of racing there.
You know, I think at the end of this, I'd like to see a race between all the rovers.
That would be great, wouldn't it? We'll set some lap records, maybe a bit of drag racing.
Yeah, it'd be really exciting and something fun for the teams to do at the end of the competition. Some de-stress.
That has been a tradition over the years as well. All of the rovers compete in a tug of war to test who has the most torque. That's always a fun way for teams to bond together. Sometimes we discover some hidden strengths in the rovers too.
And also a good idea to come out here, either join us live stream, and if you can, come out here, drive up to Roseworthy, the University of Adelaide Roseworthy campus, where you can get all of this action live in front of you, where you can walk through the workshop, talk to the teams, and see their rover in the real flesh as they work on it. We also do have some booths there in the workshop, industry partners and sponsors who have come out here that you can chat to. the Adelaide Rover team is hard at work coordinating and strategizing. They do have just about 3 minutes remaining to try and make the most of it, try and get as many points as possible. We have seen the robotic arm extend there and approach the processing plant. It looks like they might be going for that card reading task.
Potentially trying to download some instructions, manipulate things on the processing plant. 3 minutes on the clock.
Incredible effort from Adelaide Rover Team so far.
Can see the cameras on the end effector there, giving a really good first-person viewpoint where that robotic arm is headed.
Once this Adelaide Rover team concludes this task, don't go anywhere. It just shortly afterwards at 1200 hours local time, we will be having QUT Roar on pitch A for the post-landing task. And that will be the final team coming out and participating before the lunch break. We're seeing an incredible demonstration of hard work and determination.
Just over 1 minute remaining. UTS still with time left in the space resources task as well. Final team to compete before we go to lunch break. Coming back with Monash Nova Rover at 2 p.m. Looks like another attempt by Adelaide here.
With just under a minute left to go for their attempt. Effort until the last second.
Nail-biting pressure. So try to get those last points. And that is time for the Adelaide Rover team. Give them a round of applause. Great work from their rover Romulus.
Incredible determination we've seen over the past 40 minutes here for the post-landing task. And don't go anywhere. Shortly, in just a while, we will be having QUT Rover Team coming out here to complete the post-landing task. This will be the final team to participate before we go off for a lunch break. After the lunch break, we're going to be seeing University of Melbourne on pitch A to kick off the post-landing task, followed by the UNSW RAS Rover Team, followed by the legendary Rover Team, and that will conclude the post-landing task series of teams. Over on the second pitch, after the lunch break, we'll have Monash, followed by RMIT, UWA, and then we'll be concluding the second day of the Australian Rover Challenge.
So there are a whopping 6 teams competing after the break. That is plenty of approaches to the different tasks to watch. Stay tuned. In the meantime, UTS Rock E the Rover It's kicking up some sand, putting on a nice display for the audience over here who experience this sand kick up in 3D. Hopefully there's some beach towels.
I'd love to be at the beach right now in this weather, I have to tell you. As much as I love the Rovers, the beach sounds like a wonderful idea.
I did see some swimming pools nearby. It's not out of the
Oh.
question.
That's an idea.
UTS continuing to persevere here. I know we've used these words a lot. Perseverance, tenacity, determination. But it comes in infinite amounts with all of these students here at the Australian Rover Challenge.
It's a beautiful connection to the naming of some of the rovers that have gone outside our planet and to other planets as well. We had the Martian rover's Perseverance, we had Curiosity as well as Opportunity, and these are names that represent exactly what we see here, exactly what we are talking about at this Australian Rover Challenge.
iSpace as well. Their lunar lander is called Resilience and their micro rover was called Tenacious as well. All of these names reflect exactly the kind of hard work that goes into making these missions a success, even here on Earth. They have so many challenges to overcome, and the UTS GUI here is showing some interesting science data, science temperature data coming back. Potentially they're processing something on board right now. So rover is scrambling, trying to find a way out with just under 12 minutes remaining. You can see there the wheels continuing to kick up the lunar regolith.
The determination to troubleshoot, to problem solve, and get their way out of there and continue the task in the time they have remaining. And while that is happening, over here on pitch A, in just under 2 minutes, we'll be beginning the countdown for UOW Rover Team to come out here and complete the post-landing task. The team looks like they are ready to set that rover up there on the side of the pitch.
Now, we spoke to QUT Raw earlier when we took our little trip over to the workshop. Their rover is called Perseus, and it is the second iteration of this rover. Last year, they tested 2 operating simultaneously. This year, they've got Perseus 2.0.
And their countdown begins in just under 1 minute.
Oh, looks like QUT have made a move over there. Sorry, QTS have made a move over on pitch B. Did they get out of that tricky situation that they found themselves in just minutes earlier? Perhaps that collapsible suspension system really played a part in that.
We're seeing some normal movement now, which is incredible. Getting themselves out of there, problem solving, coordinating. It must have been stressful, but what an incredible effort and perseverance, just as we were talking about before. And just under 10 minutes remaining. Plenty of time for the team to go around, accumulate as many points as they possibly can.
Just reflecting on what we saw yesterday from UTS, a little bit of a setback when they tried to descend down the lander. They had to call an intervention. Compared to the performance seen today, that suspension is just incredible. Working so smoothly for the team, and hopefully they've been able to get some results out of it.
As we tick over to 1200 hours into the afternoon here in South Australia, local time, we do begin the countdown now for QUT Roar. So once again, a reminder, This is the post-landing task here in pitch A. The teams have to have up to 40 minutes to complete the task. Now they are allowed to take longer time to do systems check, preparation, ensuring the rover is ready to go, troubleshooting if need, but it does eat into their allowable time for the task. So the countdown does officially begin, but the team, once they're ready, will call initiation of the attempt. And we'll see some action here on the pitch, hopefully. The post-landing task is representing a scenario where your rover has just landed on the lunar surface. It's required to complete a series of checks and activities to accumulate up to 100 points available. One of them is descending down that ramp successfully and then roving around, reading some status messages around on the pitch, and even observing some damage and making some host connections as well. So hopefully we'll see UOW Rover attempt some of those activities today. UTS on the Space Resources task, still going strong. 7 minutes remaining. This is the final team before lunch break. This is the final team before lunch break for the Space Resources task, but don't go anywhere. We have 3 teams after the lunch break to complete each of the tasks, both the post-landing and the Space Resources.
So we will be going until 4:15 p.m. local time today. Plenty more hours of rover action left. And if you missed our leaderboard reveal earlier, you can jump on the website, Australian Rover Challenge, through the University of Adelaide, and see where all the teams stand. When we last checked in, the current reigning leader was AGH Space Systems, coming all the way from Poland, and 4 other Australian teams rounding out the top 5. And
once again, the leaderboard will be updating as these tasks will be completed and as the days progress for the challenge. Particularly the Space Resources task, once all the teams completed, will be weighed accordingly. So definitely stay tuned at the end of today and early tomorrow morning for the 3rd day. Check in and see where the teams are at the leaderboard.
It seems like the leaderboard has changed even again since we last checked in, as some of these post-landing task scores are coming through. So I'm sure we'll recap that soon, and we'll have some updated positions for you. Thank you, comms. There we go. Again, just a narrow 3 points between first and second place. AGH versus UQ. Seems like Project Scorpio has jumped up the ranks off the back of their participation in the post-landing task this morning. Adelaide Rover Team jumping up as well. RMIT, UOW, Monash. Amazing job by all the teams so far. 15 in total.
We're still seeing some action from UTS, the University of Technology Sydney, here on the Space Resources task. Even with under 5 minutes remaining, effort until the last second, as we've seen so many of the rovers demonstrate yesterday and this morning.
Another good point of view shot there from UTS. Can really get a sense of just how difficult it is for that mission control team to be able to drive around their rovers when this is all they can see of the track. Situational awareness is key. And again, the teams don't really know what the track looks like until they arrive here in South Australia for the first time early this week.
Once again, here on the post-landing task in Pitch A, we are waiting on UOW Rover, who have the rover there on the side of the pitch, and they seem to be troubleshooting, trying to get the rover operational, ready for the post-landing task. Their countdown has started about 7 minutes ago. So still 32 minutes to go, plenty of time. If they can get that rover operational, working, and we can see some action for the post-landing task.
Again, perfectly normal for teams to eat into this task time. They want to make sure they're doing all of their system checks before they cut off that two-way communication to give themselves the best chance of avoiding an intervention later on. Base station team hard at work there. Oh. And just a reminder for anyone who might have just joined us, we'll be cutting to our lunch break at 12:45 p.m. We're gone for an hour, returning at 1:45 p.m. to watch the University of Melbourne take to the post-landing task, followed by Monash Nova Rover at 2 p.m, tackling space resources over on Pitch B. One minute left for the Rocky Rover, which is actually doing a bit of rocking around. Wow, check out that suspension system. It's like nothing we've seen yet from the Rovers who've competed here on the pitch this week.
Incredible display there.
Active suspension like that, quite unique.
I feel like that was almost kind of a last play.
The Rovers' prowess.
Yeah, kind of a goodbye for the space resources task. Incredible work, incredible effort. The team coordinating in the base and even the field crew. Just fantastic work.
As it trolls away back to the field team in the final seconds. That is time up for UTS. Give them a round of applause.
Incredible work.
Well done, UTS. And we have Deakin University watching on there, cheering on the crowd. Again, the support from all of the teams, once they've competed and they take to the stands to encourage everybody else, that's the kind of camaraderie and teamwork that we love to see here at the Australian Rover Challenge. We often give out awards for best team culture, really encouraging everybody to be their best selves, be a team player and support everybody as they're all trying to do some really intensely difficult challenges.
We do also have now UOW Rover set up on Pitch A for the post-landing task.
It seems like we've got some schools arriving as well to watch the remaining tasks this morning. If you're arriving now, if you're a budding space engineer or scientist, lawyer, psychologist, or graphic designer, watch on, because you are seeing space careers in real time happening here on this
movement
pitch.
And all four wheels on the ground and moving.
Some excitement there from UOW Rover. And the rover is certainly roaring away.
Not wasting a single second as soon as they've initiated that task. to complete the post-landing task.
Establishing that all-important situational awareness.
Very unique design for this rover. We've got some interesting appendages extending from the chassis. Some systems that will hopefully help the team complete the tasks and activities required for the post-landing task.
And if you missed us earlier, this rover is called Perseus. Relationship with Artemis in Greek mythology.
Once again, if you're just joining us now on live stream or in person, this is the 5th installment of the Australian Rover Challenge. We are here at day 2. We've had an incredibly busy and eventful morning so far. At the moment, we have our final team competing before we go on a lunch break and come back with more action on the 2 pitches.
Now, to recap exactly what's happening here, QUT are competing in the ELO 2 post-landing task. They will be required to do a number of different things. First key one is to get off the lander, which they have done. We've got those tasks up there. Systems check, site evaluation, and also some maintenance. So this rover will be traversing around a fair bit of the pitch to read some status messages on different objects, download some instructions from a broken processing plant, and hopefully be able to do the maintenance required that they've gotten from those instructions to repair it. And we will get some visual cues if they do this successfully, because that processing plant will come to life. So stay tuned for everybody in our audience. You're going to see this rover doing lots of different things to prepare the site that they have landed in on the lunar surface.
Look at it go across the terrain. And just as we mentioned before, this is one of the most difficult, one of the most exciting rover challenges from around the world. Incredible action from QUT here.
Shredding up the lunar soil.
This year, the competition has 15 teams in total coming from across Australia, and even a good number of them coming from outside the country as well. Just an incredible testament to how this competition has grown since it first started in 2021, initiating by the University of Adelaide. And it was started, this competition, to build the future generation of the space workforce here in Australia. And it already has seen some of these student participants go on to contribute to the Australian space industry.
If you have a dream of working in space, come and chat to the people that you see here today. Some of them are working on things that are going to the moon in real life, and their career started here at the Australian Rover Challenge.
This competition provides these tasks and activities that these rovers have to complete as real as you can get, as close to reality as to the challenges that you would face if you were actually driving a rover on the moon or sending a lunar rover to complete tasks like this. So for example, what we see here, this task is called the post-landing task, which means that this rover just landed on the moon. It needs to go around, do some systems checks, some maintenance, fix some host connections, which is quite realistically what we would require rovers to do if we were to remote control them on the moon. Even the rules, the regulations, the restrictions placed on these teams to build these rovers is as close as you can get to how a lunar rover would have to be built as well.
And perhaps one of the most challenging aspects of the whole ordeal too is that half the team who are operating the rover, they cannot see it on the field. So if you're wondering where those rover operators are, they're inside a tent known as our mission control. Here they are. They cannot see the rover for themselves. They're relying entirely on camera feeds that they have put on board their rover. And you can see all of those cameras there. So QUT have got 5 in total, and that is all they can see. So just like a real-life space mission, they're relying on the rover's eyes to be able to complete the task successfully. What an amazing effort by undergraduate and a few postgraduate students coming here this week.
Great point as well. These are fully student designed and built undergraduate and postgraduate students in their own spare time alongside their studies, which just is incredible. The determination, the passion, the sense of community, the people that have come out here. It's just been such an amazing experience seeing these people, seeing the passion in their work, the coordination and teamwork, even though sometimes maybe stressful during this competition.
One of the cool things too is that a lot of the people in these teams are only in their first early years of university, sometimes as early as first or second year. So they are learning all of the skills they need to be industry ready from the very beginning of their studies. And you might think, I don't know programming, I don't know how to use power tools. You don't have to worry, because this challenge is so difficult that it requires innovating everything from scratch. So there's always team members on hand to teach you how to use everything so that you can contribute to the rover.
It's usually people who do push themselves out of their comfort zone and join extracurricular projects and programs like this one that end up learning so much. The beauty of it is that you don't need experience to join a team like this, to do projects like this. The point of joining is to gain that experience, is to gain those valuable lessons.
You're definitely right, Shagaf. If anything, it's your passion that will go a long way. And that's true for the space sector as well. If you've got a lot of passion and a willingness to learn, and you're a team player, then you can go far, all the way to the moon, like so many people here have.
Such great action so far from QUT Rover Team. They've transversed across the field, across the pitch, making the way all around, reading some status messages, and now they're heading for the processing plant.
Maybe a bit too keen.
Incredible approach to that task there. Conventionally, before, we've seen robotic arm extension for that task. We're seeing something entirely different here.
And sometimes these are these innovative approaches too. Looks like they've got a board holding some kind of RFID reader. Perhaps if they can get that close enough to read things, removes the requirement of trying to use a robotic arm to do the same task. "20 minutes remaining."
Only at the halfway point. Plenty of time still for QUT, who have already accomplished or achieved a set number of points so far. How many more will they be able to attain before their time is up? And once again, a reminder, once their time is up, we will be cutting to a lunch break, which will go for about an hour long. And we'll come back with the first team on the pitch at 1:45 p.m., which is the University of Melbourne, to complete in the space resources task. So don't go anywhere.
Moments like these, where the rover is stationary, can be nail-biting for the field team, who are unable to intervene until it's called by the base station, but also have not much idea of what the next moves might be. They can only wait and hope that there's something in the works. And to explain a little bit about how these rovers do operate, you'll notice that they've got no power cables or anything running from them. The rovers operate usually by a battery, just like they would in real life. And they have a big antenna on board. You can see that sort of helical shaped thing at the top. That is likely the communication system for this rover. And there is no Wi-Fi on the moon. No internet yet. So I'm sorry to say, you can't binge watch Netflix on the lunar surface just yet. And that means that these rovers have to use the same communication methods available, which is radio frequency.
Did you say there's no Wi-Fi on the moon?
Unfortunately, there is no Wi-Fi on the
Oh,
moon.
that changes everything. I was going to apply to an astronaut training program.
Oh, no.
Oh, here we go. I can't live without Wi-Fi.
Well, does it change your mind that they do have that on the International Space Station?
Oh, yeah, no, that's great. We'll settle for the International Space Station then.
You can watch movies, you can call back to home, FaceTime people on the ISS.
Although I presume the astronauts won't have lots of time to binge watch shows and watch movies.
True, they are very busy.
Given they are very busy throughout their entire day working on the International Space Station. Speaking of astronauts, what Australian astronauts have we had so far?
It's a great question. Well, we've had a number of people train to become astronauts, and some actually go to space as well. The first person who was an Australian citizen to train to be an astronaut was Philip Chapman back in the 1960s. He didn't get to go to space, but he did train for it, which is very exciting. We then had Paul Scully Power. He was an oceanographer, an Australian citizen, and he went to NASA, became a US citizen, and he got to go to space on a space shuttle mission as a payload specialist.
And of course, representing Adelaide.
No, that's Andy Thomas.
Yeah, so Andy Thomas.
I see what you mean.
After Paul Scully Power, we had Andy Thomas, who also did end up going to space and did a spacewalk as well.
That's right. So he was the first Australian-born person to walk in space, and Andy did a number of missions with the space shuttles, retiring in 2011. And his namesake, the Andy Thomas Centre for Space Resources, was established here at the University of Adelaide and was instrumental in starting the Australian Rover Challenge that we see here today.
And of course, since then, we have had one more monumental Australian astronaut, and a special one this time, trained under the Australian flag. So just like Georgia mentioned before, Paul Scully Power, Andy Thomas, all the other ones who were Australian had to give up their Australian citizenship or get a citizenship with the US to train with that country and fly with NASA. But we have Catherine Benoit-Pegg, who is actually from the Australian Space Agency. She trained with the European Space Agency, but under the Australian flag, and that is the first anyone has ever been able to do so. She completed her training and graduated in 2024. Yeah, I believe it's 2024, right. So a year ago now. And it's been incredible. She hasn't gone to space as of yet. So we are all waiting to see what this exciting career takes Catherine. And she has become an inspiration for so many around Australia, particularly because we haven't in the past had any representation like this, especially given that she's a female. But also we haven't really had much of a space industry or an astronaut training program. This could pave the way for that, for the Australians and young Australians who might want to go to space.
It was certainly exciting to see the Australian flag on that flight suit, and just a sign of things to come, really. The Australian Space Agency was established in 2018, and the growth of the industry since then has been so exciting. I mean, this challenge being established in 2021 was just hot off the heels of the establishment of the agency, and so many programs that we've seen since then. In particular, the Rover mission, led by ELO2, has just come about in the last 2 years or so. As this challenge has been happening, we've had a real-life lunar mission be announced during the time that this challenge has existed.
And there are so many lunar missions happening now as well. When we're talking about these rovers, we talk about lunar missions, but if you go do your research, there are so many private companies now sending lunar rovers and spacecrafts to the moon, and we've never seen such a great large influx of private companies sending and successfully landing and operating lunar rovers on the moon. So it's a really exciting time, not just for the Australian Space Agency, but for the global space industry as well.
And alongside Rover, we have other missions such as Lunaria 1, which is actually going to be a plant getting deployed on the lunar surface. And we have a host of Australian companies that are sending lunar payloads in the next couple of years. And if you're interested, definitely go on the Australian Space Agency website, space.gov.au, I think, and check out those missions. Check out the space careers available. It's so exciting what is possible to have here in Australia and in Adelaide as well.
And speaking of the Australian Space Agency, they are one of the main sponsors here for the Australian Rover Challenge, and they do also have their headquarters in Adelaide. So if you're not far from there, or if you're visiting, they have a free discovery centre.
A free discovery centre in the CBD, just over on North Terrace, the Australian Space Discovery Centre. They will be streaming this challenge as well, so don't feel like you're missing out on any of the action if you duck by over the weekend. QUT look like they are back in action again, making use of the robotic arm this time.
Look at that incredible design approach. Very different to what we've seen with robotic arms, extending from what looks like a linear actuator going up and down, a surface that's attached, extending from the chassis.
Just down there in the corner too, a huge thank you to some of our other partners who are all present here this weekend. You saw before, but in case you missed it, we have Boeing and Caterpillar present with information booths about careers as well. So if you're a budding space enthusiast, definitely go and have a chat.
We also have, the state government, we have iSpace, and we have the South Australian Space Industry Centre. Just about 10 minutes remaining for the post-landing task. We have UOW Rover Team on the pitch attempting some of the tasks on the processing plant over there. And once again, once this attempt concludes, we'll be cutting to a lunch break. And coming out back here at around 1:45 p.m, kicking off with the University of Melbourne for the post-landing task, followed by UNSW RAS, Legendary Rover Team. And over on the space resources after the break, we'll have Monash, followed by RMIT and UWA. So plenty of action still to take place on the second day of the Australian Rover Challenge.
QUT are on the move. 10 minutes remaining. This is the final 10 minutes of the morning. Thank you to everyone who has come out here today to watch and joined us online.
We have an incredible crowd there on the stands.
Thanks for waving, everybody. And I can see Boeing there in the background too. We've got the STEM team out in the crowd.
Some families and friends. Once again, if you're on the live stream and you're able to come out here to Roseworthy, the University of Adelaide Roseworthy campus, we've got some school groups here as well coming to witness the live action. It really is nothing like seeing it live here than watching it on the live stream. And not only that, you get to actually talk to these people, see these rovers in the flesh and bone in the workshop, see the teams as they work on their rovers, and also talk to some of the industry partners we've got here at their booths as well.
Yeah, it's amazing to see the support that we've gotten from industry and agencies wide to support the future space workforce. They can see the talent that's here this week, the hard work that's going in to really pushing ground here with this type of technology.
The sun is out here in sunny South Australia. Very high levels of radiation. We do encourage everyone to slap on a hat, some sunscreen, some sunglasses, stay safe and hydrated. But although the radiation here is not as good, levels in Australia are very concerning. On the lunar surface, the radiation levels are multitudes and multitudes higher than this. So the moon doesn't really have much of an atmosphere like the Earth does. It doesn't have an ozone layer. It doesn't have an atmosphere that can refract that sunlight. So all the radiation, just raw sunlight from the sun, is hitting the lunar surface, and that can really damage your equipment. It can really cause safety concerns for your astronauts if they're on the moon as well. So a lot of the critical aspects when it comes to designing lunar rovers like this is protecting them against the harsh environment of the lunar surface, the weather, the temperature levels, and also the radiation.
Yeah, and just like Shagaf was saying, if we thought it was hot out here today in South Australia, the lunar surface has some extreme temperature swings. Because of that lack of atmosphere, they've got nothing like an ozone layer protecting the moon from the harshness of the sun. So when it hits that surface, it can get anywhere up to 200 degrees positive during the day. And then during the lunar night, it becomes extremely cold. When the moon's not in the view of the sun and it's not receiving that heat input, it could be up to negative 200 degrees. So those temperature swings are all things that missions have to consider if they want to just survive the lunar day or if they want to try and go into the night.
Over here, we've got UOW Rover Team from Queensland demonstrating incredible maneuverability and precise movement. And we've talked a lot about that requirement, that need for that precise maneuverability and degrees of freedom that's required on a robotic arm, or the end effector, which is that end bit of the robotic arm that will complete the tasks that you'll need to complete. And sometimes, from what we've seen from the range of design approaches in these rovers, an end effector can be something similar to what we see here, which is a claw, to even something like a poking device. We've seen some very different design approaches to having end effectors. It really comes down to the task that you need to complete and how your approach to completing that task as well. With just 5 minutes remaining, what an amazing effort from QUT. Determination until the last minute. Trying and trying again and again.
Oh, so close to the... Doing a fantastic job.
They've been at this for quite some time now.
Again, just imagining there we go, that's what the base station team can see. Trying desperately the remaining 4.5 minutes to just go for it. Follow the instructions that they might have downloaded from the processing plant. Try and get it back online.
Just great effort from beginning right through to the end of this task, and still 4 minutes remaining. opportunity to attain as many points as possible. Once again, this is the post-landing task. There are up to 100 points available for a series of activities and tasks to be completed in a time limit of 40 minutes. What a fantastic display of that claw moving around there.
Can they get it done?
The suspense is building up as the task has 2 minutes remaining.
The desperation. Doing everything they can.
Stress levels are high. The base team there in the bottom right corner doing an incredible job. The past 40 minutes, just effort from the beginning to the end, coordination, teamwork, problem solving, on the spot.
You can see the coordination there as they try to problem solve this on the fly. Minute and a half to go. This is it. The final attempt at the post-landing task for the morning.
Will the Queensland University Rover Team, the QUT Rover, be able to attain some last-minute precious points in the last minute remaining?
T-minus 30 seconds, just like a launch countdown. Last minute effort by QUT. The desperation, again, the perseverance. We're going to keep using that word because these students do not give up. They're trying.
They are really going for it. Let's get some cheer from the crowds.
They are not
supporting
giving
the
up.
team here in the last seconds, and that is all the time they have.
Well done.
Well done.
Great attempt there from QUT Raw. And that is time for our morning blog for day 2 of the Australian Rover Challenge 2025. We are coming to you live from the Roseworthy campus at the University of Adelaide. They got it, everyone. We have confirmation that they got it done.
What an incredible achievement! Congratulations to the QUT Rover Team. Don't go anywhere. Shortly after the lunch break, we'll have a range of teams completing the tasks. Lots of activity to happen here on the pitches. My name is Shagaf and this is Georgia. We'll see you right after the break.
is a nation of creators, aviators, protectors, and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting, and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated, and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials, and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists, and universities. Developing new military platforms and communications networks, and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line, and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world. Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
Welcome back, everybody, from the break. We're looking here now at the live leaderboard from day 2 of the Australian Rover Challenge for 2025. Coming to you live from sunny South Australia. So we've been calling it all week, but it really has been glorious weather out here on the track. And as we can see here, the top 15 teams who have competed so far over the last 2 days in the post-landing task and the space resources task.
I don't know what you mean by glorious weather, Georgia. I'm not enjoying that blazing sun, as I'm sure many other people are trying to stay hydrated, stay in the shade. Don't forget about sunscreen and hats and lots of water.
Over here in the commentary box, you might have noticed that we've got 3 people here now. We've expanded our team. So in case you're just tuning in, my name is Georgia. I'm a graduate of the University of Adelaide in Aerospace Engineering and Computer Science, now working in the space industry. I'm joined here by Shagaf.
Yeah, so I'm completing my honours in mechanical engineering, also majoring in aerospace. It's my final year, so the final stretch of my degree. And I've also, similar to Georgia, have had the privilege of being part of many extracurricular activities, including the Adelaide Rover Team.
And we're also joined here this afternoon by Profay. Welcome, Profay, to the desk.
Hi guys, my name is Profay. I'm studying at the University of Adelaide, double degree of mechanical engineering in aerospace and physics, and I'm also here on behalf of the Adelaide University Space Society. So yeah, and I'm rover reporting this afternoon.
That's right. So you saw us earlier leaving our desks and taking a little bit of an excursion into the workshop, and we now have a dedicated roving reporter here with Profay. So we're very excited to have that opportunity this afternoon, potentially to interview the teams a little bit more, especially the ones that competed this morning, chat about how they felt about their attempt in the tasks this morning, maybe some of their strategies for the next few days, what do they plan to achieve, and the state of their rover as well. There is so much to gain and so many more points to grab as well.
Speaking of the afternoon, we hope you've had a lovely lunch break, and now we're going to be expecting 2 teams to come on and kick off on the 2 pitches. So if you've just joined us, this is the Australian Rover Challenge, the 5th instalment of the competition here at the University of Adelaide Roseworthy campus in sunny South Australia. We've got 2 pitches operating for the first time in the the competition's history. On pitch A is where the post-landing task is taking place, and over on pitch B is where we have the space resources task. Today for post-landing at 1:45 p.m, so shortly at local time in a few minutes, we'll have the University of Melbourne completing the post-landing task, followed by the University of New South Wales at 2:30 p.m. local time, and then at 3:15 p.m, legendary Rover Team. Over at pitch B for the space resources task, we have Monash University competing for at 2 p.m, and then followed by RMIT at 2:45 p.m, and then the University of Western Australia at 3:30 p.m. And there's that incredible view of the teams hard at work in the workshops, troubleshooting and problem solving to get their rovers operating and working ready to go for the competition.
So I have Profay shortly down in the workshop, finding team members to interview and interesting things to chat about while we commentate the rest of the action here on the pitch. And they're just getting set up. Our volunteer astronauts are hard at work preparing these pitches as the University of Melbourne make their way out. They're hopefully getting ready soon. They are just 5 minutes away from their task time beginning. How's the action been this morning, Shagaf? We've had an incredible morning, attempts by so many different teams. I believe 10 in total.
Yeah, it has been an incredibly eventful morning so far. We kicked off at the post-landing task with Project Scorpio. We saw what was almost an attempt from Bluesat, but they didn't get the chance to demonstrate their rover yet. We also had Deakin University, Adelaide University, QUT, WAR, all have a go at the post-landing task, and amazing achievements all throughout. For the space resources task, we had AGH University from Poland, followed by University of Wollongong, and UQ Space as well as UTS complete that space resources task. Each team bringing their unique design considerations and approaches and their very interesting strategies and tacticals working together. You can see here the base station setting up to go.
Double joysticks there. This is serious business as UniMelb Rover Team prepare themselves for their attempt at the post-landing task. Now, if you're just joining us here on the live stream, we're going to run through what those tasks involve again. The ELO2 post-landing task, and there are the points up for grabs on the screen to my right. We have a systems check, site evaluation, wireless communication and processing plant maintenance, and a hose connection. What does that mean? This task is simulating the rover landing on the lunar surface and taking its first steps outside of the lander for the very first time. And why is it going to the moon? Well, it has to fix some things that are broken. So there are a number of pieces of equipment around the track that require the rover to perform maintenance on, but they have to get the instructions using something called RFID, which is a form of near-field communication. So most of the teams will have an RFID reader equipped to their rover. They're going to try and download some instructions from a processing plant. And among many other things, they're going to read some status messages, understand exactly what's wrong, hopefully fix the equipment, and on top of all of that, if they do get the time, fix a broken gas line from the lunar lander over to the processing plant. All the teams have had to come up with a modular hose connection that can interface with one end of that hose. We might see some attempts this afternoon to get that hose connected. Now, the reigning champions of this task so far are the Polish team, AGH Space Systems, who got a perfect 100 out of 100 on this task with 4.5 minutes remaining yesterday. Absolutely incredible effort from that team. And I think we're going to see some similar kind of exciting action on the pitch here this afternoon.
Absolutely. We've seen incredible demonstrations of hard work, team effort, and just team morality and team spirit so far this morning and over the past day and a half. Once again, this challenge is a 4-day competition. It will be spanning all the way through to Sunday. So definitely don't go anywhere. Tune in and even come out here to Roseworthy if you can. Get the action live. Get to see these rovers in the flesh and bone. Walk around the workshop, talk to the teams, and even speak to some of our industry supporters and partners who are here with some booths, giving out some resources and speaking to some of the students. It really is just that incredible connection between the students and this incredible experience they're receiving, as well as the industry that's coming out here and experiencing this awesome human talent. And there we go, University of Melbourne setting up their rover, almost ready to go, with 1 minute left until their countdown begins. So just a reminder, there is a 40-minute limit or countdown for the post-landing task, and up to 100 points available, like Georgia was talking about before. The first set of points that they need to achieve is to be able to successfully descend down that lander that you see there, that ramp, which is at a 20-degree angle. And it seems like such a tedious, simple task, but it really involves a lot of design considerations, particularly with the wheels and with the weight distribution. And we even saw a case yesterday where one of the rovers almost toppled over trying to come down that ramp. So it's really ensuring that there's that careful, precise movement with the maneuverability of the rover and the wheel design, as well as the suspension. If the rover does eventually make it off the ramp and all wheels are in contact with the ground, that does give the points their first set of points. And then the rest of the points will be achieved if they complete a series of tasks and activities, which can be completed in any order, and they involve, like Georgia was talking about, navigating around, evaluating some sites, reading some status messages around the pitch on the lunar surface here, and a few others as well. So as it hits 1:45 p.m, we've officially started the countdown. Of course, the teams don't have to start straight as the time starts. They can take their time to do their final checks before they officially initiate the task. It does eat into their time available though, so they only have 40 minutes on the clock.
Can see the base station team watching intently there. This two-way communication still active. Nice signal coming from the LED on the top there, hopefully indicating some kind of positive status on that rover. Field team is walking away. And we have go from UniMelb Rover Team. Give them a round of applause. All 6 wheels on the ground at breakneck speed. Just minutes into their 40 minutes of allocated time. And around they go. Using that 6-wheel drive system. You can see the regolith just pouring out of those tyres. We've talked a lot today and yesterday about the importance of that ladder structure, making sure the sand doesn't get trapped inside.
And this is the first time today we're seeing University of Melbourne. We did see them yesterday participate to complete the space resources task. And today they're having a crack at the post-landing task here on pitch A. And while that is happening, in just some while, we'll be expecting Monash University on the second pitch to complete the space resources task. That'll be at 2 p.m. local time. And there they are, ready to go already, with 12 minutes before their countdown even begins. There's a very big cheer from the crowd there, big support.
And that, of course, was Monash Nova Rover on the screen before with their pink rover. Getting prepared for the space resources task to begin at 2 p.m. local time. So they are just 12 minutes away from their attempt at a task. In the meantime, UniMelb making their way around the lander.
Once again, unique design approaches to so many different tasks and from so many different ideas and views. And this one has a bit more of a claw-looking like end effector on that robotic arm and a very interesting wheel suspension design there.
Now the rover looks like it's moving on, having gone around the lander, surveying the landscape to see what might be the next place of attack. Remembering that strategy is a really big component of these tasks. There is limited time available, as we've seen, to be able to achieve everything required, as we described earlier. Sometimes teams will preference tasks that they feel the most confident in, while other teams might tackle what they think is the hardest first, and then try and get those remaining points in the time left. Can see that suspension system in action as it tackles the crater ridge, smoothly making its way over the way the chassis has stayed level. Nice close up there. As UniMelb Rover Team continue to attempt the post-landing task. Doing some evaluation of the sides. Can see there their graphical user interface. 8 simultaneous camera feeds. That might be a new record. I don't think we've seen 8 operational so far. Impressive stuff. You can see there just the lag that these teams are facing with these communications systems that they're relying on. Comms is everything in this competition.
Really gives you an idea of even how much harder real life applications for this would be. Operating a rover on the moon is no easier than this, and in fact would be harder from the aspect of communications and from the aspect of getting that live information. Particularly with space, we've got that delay. With the moon, it's a little less, but if you're operating a rover on Mars, there's up to a 20-minute wait, and that's at the best case scenario, one way, and even two ways, you'd have to wait up to 40 minutes. University of Melbourne not wasting a single second, making their way, some cheer from the crowd there, making a way around the field on the lunar surface. Still plenty of time to go. Will they be able to accumulate enough points to get their score and jump up the leaderboard? We'll find out at the end of the day, and tune in tomorrow morning as the judges continuously update those scores and weigh in and accumulate into the leaderboard.
I was chatting to some of the teams in the break, Shigaf, and it was really awesome to hear that, like we were talking about, that real teamwork culture here at the Australian Rover Challenge. The tent layout this year being very open plan and all of the teams being kind of next to each other has led to some really awesome moments of teams helping each other out in moments of crisis, providing tools and spare parts, and that's the kind of culture that we really love to see here. That's the sort of culture that we want to cultivate for the industry as well, and if we can kick off that type of attitude here, well, that's going to be awesome for future space missions where we're going to be having to work across borders to be able to make these a success.
Yeah, absolutely. And even it goes back to talk about that international collaboration, which we were mentioning with the Artemis program and the Moon to Mars initiative. So for those who are tuning in or weren't listening in early this morning or yesterday, we talk a lot about the connection between this competition. That's the word. I've said it so many times today. On a higher level, addressing building that future generation of the Australian space industry, the Australian space workforce, these students that you see here today, these teams, many of them will be going on, most likely going to work to contribute for the growth and for the Australian space industry. But also this competition was started to address Australia's involvement with the humanity's return back to the moon, which we'll be doing through the Artemis program.
I was going to jump in there and say that's a really good seg, because the post-landing task mimics a lot of the tasks that we would expect rovers to perform in real life. And in fact, I say the post-landing task, but really all of the tasks over the 4 days, there's been a lot of careful thought and planning behind why the rovers are doing such a huge array of different tasks. So the Rover, which is led by the ELO2 consortium, the task for that rover is going to be to descend from a lander, much like this, navigate around a section of the lunar surface and take a sample of the lunar soil, deliver it likely to a hopper of some kind, and that sample will be analysed for oxygen content. Now, if that sounds familiar to you, it is. So the Space Resources task does something very similar to this, analysing the percentage of water inside a frozen regolith sample. Similarly, again, the teams have to navigate around the lunar surface, descending from a lander, imaging the sites, and then delivering a presentation. So the mimicry of what's happening here with what's actually expected of real-life lunar missions is pretty close to a 1-to-1, minus the distance and the 1/6 gravity.
And if you're keeping up with the Artemis program, we've talked about it many times now, The program essentially is split up into a number of missions, with the first mission taking place in 2022 now, so a while back. And the first mission was kind of a test to make sure all the systems and subsystems are good to go. And what they did was they tested the SLS rocket and the Orion spacecraft, which will be carrying the humans. Artemis 2 is scheduled to take place within the next 5 years, and that one will be a crewed mission. And they have already actually announced the astronauts who are currently training for that program. They've got on that crew the first woman and the first person of color going on a lunar mission ever. And that just shows that human collaboration, international collaboration, but also the diversity that we're bringing to these missions, to going back to the moon, to establish that long-term human presence there.
You make a great point, Shagaf. This is one of the most exciting times at the moment to be getting into the space sector, and especially if you're like us and we love the moon, being able to see those crewed landings again, that's going to be a feeling that I don't even think I can imagine at the moment. Having definitely missed the space race of the 60s and the 70s, getting to experience that in my lifetime and see Australia's involvement in that on a national level is going to give me chills, I think.
Yeah, absolutely. I mean, it's one thing being alive in this time and witnessing this take place, but it's also another thing being an Australian here in the country and seeing potentially and hopefully successfully that Australia will be able to provide that lunar rover with one of the Artemis programs. It's going to be an incredible moment for the country and for the space industry here in Australia. It's really going to achieve new heights. We're already seeing the space industry here grow, and this is one example of that. The competition, the Australian Rover Challenge, growing so much from the very first competition having only 3 competing teams, and up to now we've got 15, and not just from across Australia, but a number of teams from outside the country as well.
Tuning back into what's happening here on the pitch, it looks like the UniMelb Rover team has navigated to another site. They're potentially going to try and get some kind of status message. Hopefully that'll give them some instructions. And of course, those all-important points. We saw before on the leaderboard, there's a very, very close gap between first and second place, just 3 points. So the next few days are going to be incredibly important. There are, of course, 100 points up for grabs for each of these tasks. 400 points maximum to get.
And just like we've said, 4 days are comprised of this competition. So really, this is just the beginning. We're only almost halfway through. Saturday and Sunday, we'll be bringing on even different challenges. So over the past 2 days, you've seen similar challenges faced by these teams, the post-landing and the space resources task. On Saturday and Sunday, there will be completely new pitches here that will be changed to suit those 2 other tasks, which are the mapping and autonomous, as well as the excavation and construction. So don't go anywhere if you're online. Stay tuned for the remainder of the days. If you're in person, I don't think you can go very far. Definitely stick around. And if you can come up here on the weekend, definitely do. Get the live action happening here. It's absolutely incredible. And the weather is looking to be a little less warm on the weekend, so perfect opportunity.
The time has now ticked over to 2 p.m, which means that Monash Nova Rover will now start their allocated task time. Reminder that they do not have to begin the task at that time, though. They can take a little bit longer to do some system checks, which looks like they might be doing just to be extra sure that they're happy with the rover before they kick off. I think in the meantime, we might see if we can take a little sneak peek into the workshop, where our roving reporter, Buffet, might have a few chats lined up with the team. In the meantime, UniMelb have called an intervention diagnosing what might be happening there with their rover. Multimeter is out. One of the most important tools an engineer can have when trying to diagnose what's happened with a rover. They want to be able to check the end-to-end connections between some of these wires and make sure that they're plugged in correctly. As we've said earlier, sometimes one or two pins being wiggled out of place just with the ruggedized terrain that these rovers go through can sometimes result in the loss of power or connection to systems. So being able to confirm that connection is crucial to being able to repair it.
And just a reminder, these teams can call multiple interventions if necessary. Of course, each intervention will be deducting marks, resulting in a penalty from the total number of points that they attain. But there are some cases where an intervention is necessary, and we've seen some of those cases over the past day and a half here at the Australian Rover Challenge.
We've got a bit of cloud cover coming here through the site as well. Bit of lunar night weather. As UniMelb work on their rover and Monash also work on their rover. Engineering going over time and the problem solving here happening on the pitch today. It's just been amazing by the teams.
I think you've jinxed us, Georgia. The blazing sun is out again. What an agony. It is looking like there will be more clouds over the weekend and only a high of 25 or 26 on one of the days. Whereas yesterday and today we had highs of 31 or 32 degrees. So a big difference and a great opportunity to come out here. We've got incredible on-the-spot problem solving.
Alrighty, and I think we're ready
Hi,
to cut
I'm
over.
here in the tent with Connor here from Bluesat. So Connor, this is your first time your team's competing. You're hard at work fixing up some problems with the motors.
Yeah, so what had happened was we were about to do the post-landing task and we were sitting in just before getting the actual rover onto the field and we weren't getting any comms from our motors. So what had happened was we have a CAN transceiver plugged into our main computer, the Jetson, and what had happened was there's a little chip on the actual transceiver itself which is meant to bump up the voltage that's used across the CAN line, and it just didn't work. So we basically came back to the pit afterwards, and after 20-30 minutes we figured it out and fixed the problem. So hopefully it'll get back working.
Yeah, that sounds really great. It sounds like you guys definitely fixed through a lot of challenges. So I'll just finish up with a little fun question. So if you could add one ridiculous thing to your rover, what would it be?
Probably a tail. Probably either that or like fire breath. It'd be pretty cool, I reckon. Yeah.
That sounds really good. Thank you so much, Connor. And we will move to another team. All right. Thank you.
So Buffet is going to keep rovering around the workshop there.
You don't have production.
When she's got another team lined up, we might be able to cut back later. In the meantime, that was the perfect seg because it looks like UniMelb are closing up their rover, hopefully being able to fix whatever might have happened there. Top is going on. Fingers crossed. Now the Bluesat team were talking earlier about some of the issues that they faced with their CAN motors. This is a pretty common issue. The CAN bus is one of the primary ways that the core rover system can communicate with the motor controllers to drive the rover. And if that connection isn't working, you have no drive system. And it's such a complicated setup. We keep coming back to the wires. If one CAN wire comes loose, you can often lose entire parts of your drive system. So hopefully they'll be able to diagnose that today, get ready for tomorrow.
And there we go, some action back in the game. Some rounds of applause, cheer from the crowd. Great support for the University of Melbourne here. With just under 18 minutes to go, there's plenty of time for the University of Melbourne to attain as many points as they can for the post-landing task. A reminder, there's up to 100 points available depending on the sets of tasks, each allocated a set number of points, and a total time of 40 minutes allocated for the task. Some more cheer from the crowd here. Great effort from the team so far.
You can see the glare of the sun really impacting some of those camera feeds there. Definitely a challenge for the team is being able to see if they can find a way to polarize their lens to reduce the effects of that glare. You can see there, the ability to see can often be challenging, especially in this time of day.
So while we have University of Melbourne here on pitch A completing post-landing and still awaiting Monash University to commence the space resources task, we'll cut back to Prof, one of our commentators who's in the workshop at the moment, and we'll talk to some more of the student teams in the workshop.
With Karin from Rhino Rovers, could you just talk about your demonstration rover to us?
So I am from India, and we have first time coming to Australia in this Rhino Rovers challenge, and also we are working on different active stabilization using PIDs, and also we are having a new innovative method. We are not following the same rocker bogie method, and this is the thing which we are working, and it's a new concept. We are working on it, and we are just in the demonstration team, so we are just in the prototyping stage or something like that. We'll be advancing by the next rover challenges.
That sounds really cool. So if we just take a look closer at the rover, do you guys want to let me know what you're working on in this right now?
Yeah, we are working on 6 wheels and PID. Okay, we are working on 6 wheels and PID, and we have completely focusing on autonomous. Every subsystem has been focused on autonomous. We have PID systems for active suspension, and then we are not using, as my friend said, we are not using rocker bogie method.
Yeah, I'm Chaitanya. As she told, she has worked with 6 wheels and PID, and also we are now working with rover is moving with completely on the code. It's fully based on the code, and then.
So for the first time, we have implemented autonomous navigation through robot operating system, and using RAS we can communicate it wirelessly, and it's fully AI integrated system where it can have a object detection through machine learning techniques, and it can frame its path planning algorithm which can autonomously navigate itself from one point to other. So in space shuttle we can have these kind of applications right? And coming to the part, we've also implemented this planetary gear drive system where we are hybridizing the cycloidal actuator with the planetary gear system. So we have initially tested it with 3D printing technology, which is a rapid prototyping technology. Then we have shifted the technology into metallic transfer, where we are increasing the torque load. So our future work will be totally in autonomous focus. Yeah, thank you.
All right, thank you so much, guys. That was really insightful, and we can't wait to see it on the field soon. All right, we'll go to the next team soon.
So that was the Rhino Rover Team there from India, adding another country to our list. Now, the Rhino Rover Team are a demonstration team, so they've brought their rover over from India, and they're not part of the points, but they will be demonstrating their rover at some point on the pitch. So exciting to see there. They've got some development. We heard the words PID before. That's talking about the tuning of some of their systems with signal analysis. For now, it looks like UniMelb have made headways over to the processing plant. They're going to undertake the next stages of the post-landing task, while Monash Rover are still working on their rover. Plenty of time left, though, in that space resources task time slot. If you were here before the break, you would have joined us for the nail-biting effort at the end from QUT Raw to complete similar tasks to this. They're able to get in at the last second to activate this processing plant, which is currently broken.
And we've talked a lot about robotic arm maneuverability, degrees of freedom, and trying to mimic a human arm almost in that precise movement in order to complete these tasks effectively. And once again, we might cut back to the workshop where Profay is still speaking to some of those students in the team.
All right, so now we're back. We have Nigel here from Q Teams. Nigel, could you tell us what?
Yes, so thank you for asking. We've just completed our post-landing resource task, and I'm just demonstrating here the teleoperated arm we had. So for this task, we had an arm on the front of our rover, and this was teleoperated by one we had in the control base station. And, it's pink because my 6-year-old daughter decided this was the best colour to print it in. It's a 6 degree of freedom arm, which we use to just complete the actual task. And yeah, we had a lot of camera feeds seeing what we could do here, but as we move this arm, we're able to move the arm on the rover and score points by interacting with the subsystems out there in the field.
That sounds really cool, Nigel. Did you have any challenges in the process of making?
To what we wanted to do and to make sure that we actually had control. But found a particular model was that we had a price that actually afford in the budget to be able to have one with 6 degrees of freedom to operate with, and one being mirrored on the actual rover itself. So yeah, there's a bit of challenge, a bit of constraint, but we got there.
That sounds so good, Nigel. Thank you so much. That was quite... And we'll be back with the next team soon.
So you heard there about a teleoperated robotic arm. What that means is when they have that arm in the base station, they can move the arm and that will perform the same operation on the robotic arm on the rover that's out on the field. That is just incredible. That potentially saves some of the precise movements needed by a human operator if they can visually move an arm in the direction that they want it.
And a bit of a status check here on the pitch. We still have University of Melbourne attempting some of those tasks on the processing plant, which, as you can see from the cameras there's buttons, there's knobs, and even a keyboard. So a bunch of things that these rovers can do. And should they achieve or complete all of these tasks, they'll get a very good number of points. And they're going for one of the buttons, it seems. Now, while University of Melbourne is completing the post-landing task, on the other pitch, where the space resources task takes place, we are still waiting Monash. Monash Nova Rover has had their countdown begin at 2 p.m. local time. So they are doing, at the moment, troubleshooting, maybe facing some setbacks but it does eat into their time allowed for the task. So they still have 23 minutes remaining. If they can get that rover up and working, will we be seeing some action from the Monash Nova rover today for the space resources task?
We can see the team is set up in the base station there. They are preparing to compete today. As we've talked about a few times throughout this competition, different teams may concentrate on different subsystems every year, incrementally improving their rover design. Maybe Monash is test trialing something new this year, having to swap out some payloads and just really checking that everything is up to satisfaction. And they picked it up. You can hear the cheers of the crowd. Very excited. Monash Nova Rover cohort over there as their pink rover makes its way over to the field. Now, we spoke to this team earlier about that bright pink colour that they've got on the chassis there. That's some more noise from the crowd there. Hopefully that's a good sign. And this bright pink colour is symbolising the efforts and the outreach initiatives from Monash to increase diversity in STEM, get people talking about pink, why we need to see more pink in STEM.
And coming back to University of Melbourne here, still great efforts we're seeing at that processing plant. With 6 minutes remaining, we've seen a range of rovers, a range of rover teams attempt the processing plant tasks. We've seen different design approaches with the robotic arms and some without a robotic arm attempting to complete some of these tasks. Will University of Melbourne be able to achieve some precious points in the last 5 minutes of their time remaining?
How do you work, Tony? I learned from the best.
Wow, look at that. Task that might seem simple for humans to complete is so much more complex for a remotely operated rover. Manipulating the buttons on that processing plant, using their end effector, incredible stuff from the team. And to think if we can build this capability now, imagine what this would be like on the lunar surface. Sending rovers out into that harsh environment to complete tasks before the humans have to, or in lieu of humans. Can make those dreams of a research station a reality. Rovers and humans operating alongside one another. Sending those rovers out. Some more cheers from the crowd. Monash have come back, potentially doing some last minute fixes there.
We're seeing some very quick runners around, and they seem to have moved away from that Nova rover on the second pitch there, indicating a good sign that they're ready to attempt their space resources task. So a reminder that once they call initiation, and there we go. Big support from the crowd there as the rover makes its first move on the pitch for the space resources task. Of course, now that they've started the attempt, all communications between the field crew and the base team in that mission control is cut off. So all the information that the mission control have to work off is what they see on their monitors. So their live camera feeds and sensors and all that stuff, which you can see here, 8 simultaneously working live camera angles. Incredible wheel suspension design and maneuverability on the dime rotation, like we saw with the Adelaide Rover Team earlier today. Although they've just started their task, there are still 18 minutes remaining, so they will be able to attain points should they be able to work effectively. We'll see some incredible action from Monash Nova Rover here. And there's that overview of that space resources task, which basically comprises of prospecting, excavation and space resources, essentially meaning that they must be able to go around and analyze these different samples using instruments and sensors. And then once they identify the sample with the most valuable resource, they will need to be able to extract it and even process it on board if they can. That's what the task is, and up to 100 points available.
As we saw there before, they had as well 8 simultaneous camera feeds, rivaling UniMelb for the record. Can we get a 9th? We can see down in the bottom left corner, they're getting some all-important data, wheel telemetry, the power distribution between the different wheels, and the drive speed as well, helping those operators to know exactly how the rover is performing. With just 16.5 minutes remaining, they've already made their way over to a site. Are they prospecting? Will they be able to image the site? Stay tuned on this pitch. You can see down the bottom they've got a microscope kiln. So it looks like they do have some kind of ability to process a sample if they can extract it. And they're moving on already.
Monash Rover Team not wasting a single second ever since they got onto that pitch and initiated their task. In the meantime, we're still seeing some action from the University of Melbourne Rover Team here on pitch A. Even with just under a minute remaining, what a tremendous effort from the University of Melbourne team from beginning to the end of their post-landing task, and a cheer from the crowd there. Great support for all the teams all around. It's incredible to see. And that is all the time for University of Melbourne's post-landing task. Well done.
I think I saw some extra cameras pop up on that GUI at the end too. Maybe setting a new record. Meanwhile, we saw some team members from Monash Nova Rover leaping out of the grandstands before. Hopefully a sign, as they've all gathered in the corner to watch their rover undertake the space resources task. Clearly this has been quite a momentous occasion for them. We'll have to try and chat to the team afterwards and see what went down. And while they're over on the pitch, our roving reporter, Prefay, has got another interview lined up for us over at the workshop as we wait for UNSW RAS to get set up at 2:30 p.m. local time on pitch A. Prefay, how's it going over there? She's just getting ready over at the workshop. Starting to get a bit of solar wind.
Another interview. I have Izzy and Z with us here today from UTS to talk about their rover. So you guys just competed in the space collection. So tell us about that.
Yeah, we did so good in this task, especially in comparison to yesterday where we did have some issues with our post-landing, but the team crunched so hard and we did amazing. Everything worked perfectly, all of our drive systems. We got water collected, which was amazing, imaged all the sites. So yeah, I'm really, really proud of how we went today.
Yeah, that sounds so good. I'm really proud of you guys too. You guys seem to be really happy with how you did. So looking at your rover, you actually have quite a great invention. Could you just talk to me?
Yeah, of course. So we have 4 independently controllable linear actuators on our rover, and they can move at 20 millimeters per second, and they allow us to adjust our height of our rover to get us down really low to the ground and then really up high off the ground as well. Yesterday, even though we had all these issues, it really saved our rover. When it tipped over, we were able to ride it back up and get it in a good position. It also allows us to, it's really an adaptive suspension system, so we can really traverse all kinds of obstacles using it. It's a really handy system, and it makes for a cool, the rover can do a cool little dance when we play around with it sometimes, yeah.
Well, you must need some speed to be doing the dance. Could you talk to us about the speed of a rover?
Yeah, so we think we have the fastest rover here at ARC 2025. It's just dangerously fast, our rover. It can go, you can't run after it if we unlock the speed limiter on it. So it's definitely able to move 50 kilos around very, very quickly.
Yeah, the must be amazing. Well, thank you guys so much for the insight on that, and we'll be back with another interview soon.
Thanks for that interview with UTS, and I think we would agree over the commentary box that potentially they do have the fastest rover. I'm still of the opinion that we need to set a lap record here on the ARCH track, so still more to unfold over the next few days. And Monash Nova over here, we heard a few whoops from the crowd, potentially a good sign that they're able to excavate this site. And check out that linear actuator and the rover actually lifting off the ground as they collect a sample. Look at that. Amazing stuff here from the team.
Again, such a unique design approach here. Not something we've seen before in the Space Resources task. And some great signs from the team there. They've got a great committee group out who are supporting, clapping along. Another round of applause for the Monash Nova Rover. They're on pitch B with 10 minutes remaining to complete that Space Resources task.
You can really feel the passion and the excitement from the audience. Monash have come over in a huge contingent from Melbourne. You can really see the love for their rover from the team. I'm sure they're all extremely proud of where they've come. I still want to know the backstory behind the guy in that poster. Someone's going to have to come over and explain it to us. But the team are really passionate and very, very excited about their rover. And similarly, hearing the passion from UTS before as well, after the setbacks they had yesterday in the post-landing challenge to make such a huge comeback in the Space Resources task today, that active suspension really playing a huge part in their performance. They've just got to pat themselves on the back. That is just a phenomenal achievement. And I think we're going to see a lot of similar stories from teams over the next few days as they learn more about their system, tinker with it in the workshop, and really get the most that they can out of it this week.
As the Monash Nova Rover team is hard at work with 9 minutes remaining here on pitch A for the post-landing task. It is 2:30 p.m. now local time, so the countdown has begun for UNSW RAS Rover Team, who is on the sidelines there getting their rover up and ready to go. Still doing that final systems check, and hopefully we can see some action this afternoon for the post-landing task.
That is RMIT there, testing their rover. They're coming up at 2:45 p.m. on the Space Resources track just after Monash Nova Rover, who have just under 8.5 minutes remaining. Speaking of active suspension, I think this rover might have that ability as well. Look at the ease of that drive system, those motor controllers just so fluidly turning each of those wheels around to go between forward and rotation movements. Just incredible stuff. Again, these are student teams, just in their late teens and early 20s. The innovation here is just mind-blowing.
Once again, talking about that systems engineering and integration of the subsystems, we've talked a lot about that yesterday, Georgia. A lot of the times to get something like this working in harmony so effectively, so smoothly, requires that critical aspect of systems integration, making sure all the subsystems are working together in unison. The drive system, the wheel suspension, the wheels themselves, just as much as all the other systems on board, including that robotic arm. And here on pitch A, we have UNSW RAS coming up to set up for the post-landing task. Still 36 minutes remaining, so they haven't eaten too much into their available time. Once again, 40 minutes for 100 points is what's happening here for the post-landing task. We'll wait for the teams to call an official initiation of the attempt. Once they do, all communications will be cut off between the field team and the mission control crew.
More drive skills being showcased there by Monash Nova Rover. You can see the processing system on the front there. Looks like they've got some kind of installation on the top. I wonder if that's a way to heat up any frozen regolith they might have. Find out the percentage of water content contained inside. Reminder too that the team will have to present in the Space Resources task afterwards. And there is UNSW RAS off the lander, so that's some points. All four wheels on the ground, plus their Space Saver on the back. Heading around to the back. Again, making great use of time. Just 5 minutes into the task. Close up of the sand just pouring out of those wheels. We love it when teams have a bit of fun. That Space Saver on the back is a great example of this. Spare tyre, should they need to go and do a bit of a pit stop.
All eyes on that Monash Nova Rover.
This is like Indiana Jones. Archaeology style. They have a brush. Oh my gosh. Absolutely excavating in a way that I don't think anyone here in the commentary box could have predicted.
Once again, never a dull day, never a dull attempt at the Australian Rover Challenge.
Is that a heat gun attached? I think it might be. So they might actually be trying to melt the regolith in situ rather than take it on board. Look at the switching on that instrumentation there. I can see why everyone was so excited. I can't believe my eyes.
We're seeing more action than we have at the Space Resources. Typically this task requires lots of idle time with analyzing, inspecting, and then instructing. But we're seeing a lot of that live action here from Monash Nova Rover Team. Incredible switching between those instruments. A beautiful close-up view there as they have just over 3 minutes to go for their space resources task. That is very adorable. Crash, there we go. Cheers from the crowds.
If you're rubbing your eyes at your screens because you can't tell the difference between sci-fi and reality, this is real life. These student teams coming up with so many unique and innovative ways to get to that regolith. This is happening right now live at the Rover Challenge. Check out that microscope view. You can really see the particles. That must be how the team in the base station is able to use that brush to wipe away what they don't want, just to extract what they need. They're scrambling here, 2.5 minutes remaining. I'm sure the tensions are high right now. They've just showed an impressive display of those systems. Can they get the points from it?
No cheer from the crowd there. What a monumentous effort from Monash Nova Rover. And of course, just as this task will be wrapping up soon, this isn't the last of Monash Nova Rover. They will be back over the weekend to complete the remainder of the tasks in the competition, coming back tomorrow morning to do the excavation and construction task. And then we'll be seeing them again on Sunday for the mapping and autonomous task as well. So stay tuned and come out here over the weekend if you want to get the live action. You want to feel the atmosphere, the crowd cheering on that rover.
The cheers are just getting louder and louder as we see the microscope zooming in on whatever it is that they're trying to get from that sample. This is an undergraduate team for people watching at home, showing the kind of technical prowess that we've seen throughout the week that you would expect from professionals with decades of experience.
And I must say, we're a very big fan of that user interface there. Just all that data display. Incredible work from the Monash Nova Rover.
Just 15 seconds remaining. How many points can they get? They've got their own countdown going too. 5, 4, 3, 2, 1, and that is time up for Monash Nova Rover. You can see one very excited team over there, coming all the way from Victoria, a veteran of the Australian Rover Challenge and the University Rover Challenge overseas in the United States. That is the end of their time today.
Stay tuned for the Space Resources task. We'll be joined by RMIT very soon on that pitch to have a go at the Space Resources task in just about 5 minutes. But cutting back here to pitch A check-in with UNSW RAS team.
I think they're attempting the hose connection. Don't know if we're allowed to say yet how they're going, but for those in the audience who can see, we've got a thumbs up from the judge. They're backing away very cautiously from that hose connection. One end of the gas line to the lunar lander.
It seems while we were distracted with Monash Nova Rover's incredible array of instruments there for the Space Resources task, UNSW Canberra team has been hard at work achieving some of the tasks and activities already in the post-landing pitch over here. Look at that actuator going up. It's an incredible design approach here.
guide rail on the front, giving them a lot of height in the Z-axis, so it doesn't get in the way of the drive system. All of these aspects require careful thought and planning by the team. We've spoken so much about systems integration, but it just can't be ignored. All of these components have to be carefully considered within the requirements of each other. A guide rail like that could make or break a rover if it gets in the way of everything else.
Can we continue the science test?
They have just under half an hour remaining. Again, the suspension system trying to navigate its way over the ridge of the crater. Coming up now to another site for evaluation. We'll see if the judges give us a thumbs up. They can successfully complete the next task. I'll be waiting to hear from the base station team if they can read any status messages. Monash Nova Rover have exited the field, making way for RMIT that are going to be on the pitch in just 2 minutes, so don't go anywhere, stay tuned. There will be another attempt at the Space Resources task in just a minute or two. RMIT will be followed by the University of Western Australia, rounding out our attempts at the Space Resources task today. Getting a little bit of lunar wind here on the site now, kicking up some of that regolith. In reality, lunar regolith on the surface is actually electrostatically charged and is highly sensitive. One of the biggest issues encountered by astronauts during the Apollo missions was that lunar dust getting onto their visors and in their astronaut suits. I was saying yesterday it's made up of highly abrasive materials, and it's still a challenge faced today by engineers trying to design things for the lunar surface. It's how to mitigate that dust effect. Once it's disturbed, it can often float up to about 1 to 2 meters in the air for some period of time, particularly in the lower gravity levels. UNSW Canberra RAS making their way to another site, backing out of the crater. RMIT is waiting in the wings over there. Similarly to what we've seen over the last 2 days, teams will often do their system checks just outside the pitch before they make their way onto the track. So we've seen quite a few tasks today, and we're going to cut to the leaderboard now. Again, just 3 points between those top two, and look at the changes there. QUT jumping up the ranks to 4th place, Project Scorpio in 5th, and the same top three, AGH, UQ and Monash. Just below the top 5 we have UOW, RMIT, Adelaide and RAS Team, the UNSW Canberra and UniMelb rounding out the top 10. You can see there's just a handful of points in between those places, with 100 points up to grab for every task. This can change at any moment. Don't be fooled by the current leadership standings. There's two full days of challenges to come.
UNSW RAS Rover Team is here, still attempting the post-landing task. They seem to have made their way over to the processing plant. Will they be able to get some points from those knobs, buttons, and keyboard on that processing plant? Stay tuned and we'll find out. They do have 23 minutes still, so plenty of time to accumulate a lot of points and bump their position up on the leaderboard.
And that's RMIT there doing some checks. They are, of course, allowed to start the systems and drive the rover around in that section outside the pitch. Once they put it down, they'll have to keep it stationary until they officially start the task. You notice a lot of people wearing cat hats out the back this weekend. It's from one of our sponsors, Caterpillar, who are giving away these cabs. Very cool. They say 2025 Australian Rover Challenge on the back. So make sure you drop by their booth if you want to get one for yourself. Potentially UniMelb here, UNSW Canberra. Where's my head at? Potentially they're going in for the RFID reading. Something that has stumped a number of teams over the last 2 days, and quite a complex system to be able to integrate onto the rest of the rover, requiring a bit of understanding about the data extraction behind RFID. Again, not something really taught in uni degrees. It's part of this extracurricular endeavour.
While UNSW Canberra team here are still completing their post-landing task and only about halfway through, over on the Space Resources pitch, the countdown has already started for RMIT as of 2:45 p.m. local time. RMIT seem to be doing some systems checks or troubleshooting to get the rover up and running. And this is something that we've seen quite commonly now since the beginning of the competition. And so on that note, while we wait for RMIT, and UNSW Canberra is doing an incredible job at that post-landing task, we're going to throw it back. Just before we do, though, RMIT seem to be carrying their rover over to the pitch now. Let's get a round of applause and support. Great effort. We might be seeing some action soon. But we'll cut quickly to the workshop again to talk some more to the students.
All right, welcome back. I've got Cooper and Canal from the Adelaide Rover Team. Canal, could you tell us a bit about how you went in the competition this morning?
So today we went through our task and we kind of went in guns blazing, but we did well, but unfortunately locked in and got our motor stuck in the rock. So in doing so, we just needed to go with more driver training today, and that is what we'll be doing later today. And as well as that, our arm actually got stuck due to some really tight cabling. So hopefully, after some rework today, and after our autonomous task tomorrow, we should have it set for Sunday.
That sounds really good, a really good plan. What are some teamwork strategies you guys have implemented, Cooper?
We've really worked on just, teamwork strategies. I guess our communication's actually been very good within our base station. We've had they had a very good time just being organised and making sure we know what actually we're doing in the task and trying to plan it out beforehand. We had them out beforehand, actually planning out the route we were going to take. It's just we need to update that route for next year, just because we did get bogged in that sand when we really shouldn't have. But I think it's very much easily something we can improve on. So I think our teamwork's been really good this year. We've been really communicative with each other, and it's actually been really nice.
Yeah, that's amazing. It's good to hear that there's good teamwork going on, good communications. Is there any other secret little features about your rover that you'd like to tell us about?
Well, we have our one main secret. It's hidden, but we have a sticker in the heart of our rover, and it is the AUS AUSS sticker. So, and that is part of our rover, and that is what makes us, well, our sister company, with us at all times, and that's what makes us Rover, and what makes us the best team. I don't know.
If you're an Adelaide Uni student, check out the AUESS Conspiracy Night. It's probably one of the best events a uni club holds all year. It's very fun, it's very creative, and there's free pizza as well, so yeah.
Really makes us not just the best team, but like in a social aspect. We're all connected together, and we may or may not be the best in terms of our output performance, but really we're here to have a great time, learn, and just have fun with fellow nerds.
Love that. Thank you guys for the AUSS promo. Do not force them to do this. But thank you so much. We do have, if you want to check out our socials, we are on Instagram, LinkedIn, Facebook, any of those things. But yeah, I will come back with another interview very soon.
Thank you, Profe. And yeah, it is incredible to see these teams work together, and within the Adelaide University, to see those clubs collaborate and cooperate. And the Adelaide University Space Society, which is that AUSS acronym they were talking about, is one of the biggest student clubs on the University of Adelaide campus, bringing together space nerds, people who are wanting to get into the space industry, in particular the South Australian space industry, and really connecting those students with the industry as well. Back here on the pitch, 16 minutes remaining for the UNSW Canberra Rover Team. They've already done an incredible job and attained a great number of points. Will we be seeing some more action? RMIT did get their rover on the pitch for the Space Resources task over there on pitch B. We haven't seen any action yet. Wondering if the team is ready or has initiated the attempt. Perhaps the base station team is waiting to make connection, or perhaps they have made connection and are strategizing. That's the word, isn't it? There's that base station team from RMIT. Once again, 30 minutes remaining, so there's a 40-minute countdown. They still have plenty of time. We're hoping to see some action from RMIT for the Space Resources task. Now, once these two rovers on these two pitches have wrapped up, we'll be joined by two other teams to complete each of the tasks, and that will then afterwards wrap up the second day for the Australian Rover Challenge. So here on pitch A for the post-landing task, once UNSW Canberra team is done, we'll have Legendary Rover Team out here at 3:15 local time. Over at the Space Resources pitch, we'll have UWA right after RMIT at 3:30 p.m. local time. And ending that Space Resources task around 4:10 p.m. will conclude the second day of the Australian Rover Challenge 2025 here at the University of Adelaide Roseworthy campus.
And here's some cheers. It looks like RMIT are on the move. Huge efforts by the team, who delayed the start time of their task by about 10 minutes. But an effective 10 minutes because they still have 30 minutes remaining. That flashing indicator on the top there, making that rover very visible to the audience. Over on the other pitch, it seems like UNSW Canberra in their final stages might be trying to attempt another crack at the hose connection. So to recap, they successfully got one end of the hose on the lander, Now they have to try and get to the other side to complete that connection. And they do get points for nudging the hose too. Can see some field team members out here watching this nail-biting action. So Rover tries to get as many points as they can. Not being able to communicate with anybody in the base station. There's a lot of trust between both sides of the team. For the field team to set up the rover, the base station to operate, the field team trusting that they're able to undertake all of the tasks. You can see there the attempts being made. I can imagine it's the same feeling of being at an arcade, Shigaf, doing one of those claw machines, and you're so close to getting the prize, but you just can't quite get there. The frustrations, but how great the feeling is if you can get it. We'll find out later.
Except the only difference is at those arcade games, I never end up winning. So really, we've seen some successful attempts at the host connection so far. The arcade games, however, is just a lost cause, I reckon. The suspense is really building up here as UNSW Canberra Rover Team attempt to make that hose connection to the processing plant, which will really give them a set of points that can bump the position up on that leaderboard, which once again, stay tuned to check, and you can also check the leaderboard live on the Australian Rover Challenge website.
Oh! Just some sensational moments this week. So many unique attempts by teams to complete the same task, but every single attempt has been entirely different. It's just what makes this challenge so difficult, but so much fun for everybody here.
We've just stick to under 10 minutes remaining for the post-landing task that UNSW Canberra Rover Team is attempting here. We'll come back to this in a second. Let's go back to Prefay, who's still in the workshops, still making her way around to the rover teams.
Prefay's going to be chatting to an audience member who's been watching us here today. Here she is. Go Prefay.
Welcome back. I am out here with the audience, and I'm here with Aiden from RMT. So, as RMT is actually competing right now, what are some of your feelings?
Yeah, so it looks like we're just having some issues but I know our great work, and the whole team is doing really well, and I'm glad to see it actually performing.
Yeah, that's so really back. And RMT, even though I'm not sure what's going on right now, but I'm sure you guys were performing great before. But is there any words of support or final words you want to say to your team?
Just 3, 2, 1, go Rats!
And there you have it. We'll be back for another interview soon.
Awesome stuff. Thank you, Prof. And that looks like incredible support team there on the stand for RMIT, who are on the space resources pitch, attempting the space resources task. They still have plenty of time, clocking only 16 minutes into their task out of the 40 minutes available.
That talk about traction before is definitely one of the key challenges for traversing over the lunar regolith. We've seen that every single team has gone for a different wheel design, and it's how the team predicts that their rover is going to be able to get the traction they need to be able to drive around. Because every rover is going to have a different center of mass. Every wheel design needs to be uniquely designed to be able to support the rover's weight, be able to get enough surface area coverage on the surface to be able to drive around comfortably. It's again something that you can't always predict until you're here on the track. So we go to a close-up here now on UNSW Canberra. Again, that end effector, full extension here. Making great use of that guide rail mount that they've got on the front. Spoke earlier about the systems integration to get something like that working, not impede your core drive or communication systems, not have any interference there. Huge effort by the team. Every team gets to set up their base station from scratch as well. So you'll see many different combinations of screens over the weekend. There's always a rush of adrenaline when it's your team start time. You've got 3 monitors in your hand, Ethernet cables coming out of everywhere. So you try to set that up and get everything booted up so you can be ready to establish comms with the rover when it's time to go out to the field. Yet another challenge, logistics-wise, the teams have to consider. We have a contingent of people from UNSW Canberra watching here on the sides. These nail-biting last few minutes as the team attempts to manipulate the processing plant. Can they get it back in action? I'll be looking for some visual confirmation from the plant, some movement to indicate that it's working and that they've been a success.
Now just under 5 minutes. We've seen tremendous effort from this team, and it looks like they're determining to continue and persevere until the last second to obtain as many points as they can in their final moments of the post-landing task. We're hearing some cheers from the crowd.
And that's a Monash Rover Team, and they're probably debriefing their space resources attempt today. Might have to get Prof over there to check out what is the source of their excitement today. RMIT, still stationary on the track, but you never know in this competition. Still just under 20 minutes remaining. That is plenty of time. As we saw with Monash Rover, they came on with about 10 to 15 minutes left and got plenty done. Doesn't seem like a lot, but you can be efficient. We can see here innovative attempts by UNSW Canberra. You can see they got a button presser featured there on their end effector. Very unique. Clever way to approach the challenge.
Not something we've seen so far on the Australian Rover Challenge. And once again, going back to each team bringing their own unique, innovative approaches. Every single one of these teams is attempting to solve the same challenge, but we're seeing such a diverse approach to actually solving these challenges.
And if you're watching on in agony like everybody else here on the pitch, remember the base station team are looking through the rover's eyes. Whatever the rover can see, if it can see at all, is what the base station can see. Hopefully they have some camera feeds, but if they don't, they might be pressing blind as they drive away from the processing plant. What are they going to do in their final minutes? It's RMIT continuing to problem solve. It looks like they have called an intervention. Two-way communication is now open between the field team and the base station team, where they're going to hopefully diagnose what's wrong. Similarly to as we saw with teams earlier today. Looks like they're going for a reposition here, potentially calling back to some of those traction issues that they had earlier. Try to find some different terrain that will enable them to get to some sites. So set it down here.
In moments like this, it's all about team coordination, strategy, on-the-spot problem solving and collaborating, where stress and pressure levels are really, really high. And going back here to UNSW Canberra, just under a minute left of their attempt now. We've seen some very unique and innovative approaches, and they're still attempting one of the tasks here at the post-landing pitch. Even with 30 seconds remaining, what a tremendous effort we've seen from the team right from the beginning until the very last second, and we've seen that a lot here today.
So close. This host connection is going to plague some people's dreams tonight, I'm sure. 2, 1, and that is time on UNSW Canberra. Fantastic effort from the team. What a job, so close. The judges are checking now. Were those buttons depressed? Not sure. It's checking. We'll wait on some confirmation here. Maybe. Potentially that's a no-go. Amazing effort either way. While we wait for the setup from a legendary Rover team, we're going to throw in another interview. We have Profay, I believe, over in the workshop. Profay, how's it going?
All right, welcome back. I'm here with Noah from Swinburne Rover Team. Noah, your rover looks absolutely incredible with the bold reds and blacks, as well as the spider-looking design. So what was your creative thoughts behind that?
So Spider, as we call it, we built it over a year. We wanted to do something different. A lot of teams come in and there's a certain meta. We wanted to think outside the box. We took a lot of inspiration from the Sherpa TT. We're constructing our rover around like a 2-year plan. We want to make sure that we get some core systems going. So we're unfortunately not able to compete at this competition. We've had a few issues electrically. But yeah, so we're working towards stuff like active suspension, pivot steerings, all those things that I think are going to make us a really strong team, a really good foundation. So yeah, a lot of cool things are coming out of it. I mean, as you can see this one, we did our first mechanical test yesterday. So if you come here, and it's been really great being in the space. So RMIT have actually lent us sheet metal and quick clamps. So we snapped our pivot steering gearbox yesterday because electrically we lost our back left wheel. So 1 second delay, front left wheel kept going, went at an angle, had a snap. But we're still able to do more testing today, so we're really grateful of all the support from the teams around us. It's been an absolutely amazing experience so far.
Yeah, that sounds really great. A lot of helping from the other teams as well, which we love to see at this competition. So thank you so much, Noah. I'll be with another interview very soon.
Thanks, Buffet. That was very interesting to see. I did pass by the workshop earlier and catch a glimpse of that spider rover, spider-looking mechanism there. It's not something that this competition has seen demonstrated before, so I'm really excited to see that take place. And it looks like RMIT has got some instruments going with 12 minutes remaining on their space resources task.
Look at that drill. So menacing. Coming down from the rover there. A reminder of the points up for grabs in the iSpace space resources task. The team repositioned their rover to be over one of the prospecting sites. And boy, oh boy, are they testing this excavation system. I would not want to be in front of that. That is a mean-looking excavation tool. Just another one of the many unique methods we've seen in this challenge to cut through that frozen regolith. Much, much harder than it sounds. Even if they break those first few layers, they need to be able to still core a sample. Can they do it?
I have to say, today's space resources teams have had an incredible display of some of the instruments, some of the technology, and conceptual designs. And look at that user interface we're seeing here from RMIT.
A lot of science information there. Can see the team jotting down some notes for when they have to deliver the space resources presentation following the conclusion of the task. Seems like they're able to get some good data on their drill position, potentially even the temperature of the regolith as well. And see some water sensor data there that they might be able to get, giving them a really good indication of the success of their instrument. How crazy is that? It can almost get like a progress bar of the drill. Again, something that we have yet to see from the teams in their GUI. This type of visual information to be able to toggle it using their GUI. I think in the top right-hand corner, that might even be a camera of some sort.
What an incredible display here from RMIT. Under 9 minutes remaining. But we've seen a great effort so far. And look at that. If you look closely, you can almost see the outcome of that effort there and a cheer from the crowds. And while RMIT is completing that space resources task, back here on pitch A, we do have Legendary Rover Team back again to complete the post-landing task. This is the final team that will be completing the post-landing task today, the second day of the Australian Rover Challenge. We've got the rover set up and ready to go. The team is running back and forth across the pitch. Excited, and it must be nerve-wracking. The countdown has officially started as of 3:15 p.m. local time. 40 minutes available, 100 points up for grabs. Will the Legendary Rover Team be able to complete all of the tasks or enough to get them up on that leaderboard? And there's that base team there setting up in the mission control room. We talked a little bit yesterday. There's some movement there happening. We talked a little bit yesterday about the design approach here and that incredible mesh wheel suspension design attachment there that provides an incredible leverage in terms of your weight distribution and your weight reduction as well. As we've said before, these projects do come with rules and restrictions, and one of them is a weight limit. So there is, depending on the task, for the post-landing task, a 50 kilogram weight limit, and every rover does have to be weighed before they go onto the pitch to complete any of the tasks. And there is also a cost limit of 35,000 Australian dollars as well. Let's get a round of applause for the movement here. All 4 wheels on the ground. There's that first set of points for the legendary Rover team.
That had me stressed out from over there. We could hear the crunching of those metal additional threads that they have on the wheels. Worried for a moment that they might puncture their own tire, but they have recovered and they are on the lunar surface, traversing around, ready to begin the post-landing task. See how they go.
I'm not sure if this team had those additional metal pieces on the wheels, did they, yesterday, Georgia? Which just shows that these teams are working day and night in this competition. It does not stop. The workshop opens until about 8 or 9 p.m. and it's open from about 7 a.m. in the morning. It's going to be a long few days for these teams, and they've been working to get here so hard over the last year or even multiple years. So really, we're seeing a culmination of so much effort from so many different people, and even the lessons they learned from the tasks they do yesterday or today. They're going back afterwards and they're making improvements and they're strategizing and they're coordinating. So it's just incredible to see that come out into play here.
I hope they're all staying caffeinated because we are only halfway through the Australian Rover Challenge when we get to the end of today. There are 4 days. We still have the entire weekend as well. Look at that wheel. So potentially made some modifications overnight to improve the traction on the lunar surface there. Close up of that organic suspension structure that Shagafa was mentioning earlier. We were postulating yesterday whether this might have been using generative design, an emerging technique for engineers who use computer-aided design programs for modeling. Makes use of AI to be able to fill in the gaps of where your stress concentrators and load limits are so that you can understand better where the rate reduction needs to happen. It gives you these nice organic-looking structures. Great use of the robotic arm there. Check out that bird's eye viewpoint. The base station team are seeing there, looking down from the top of their end effector as they go around the back of the lander. Wonder if we might be able to check back in on RMIT as well and see how that excavation was going. Seems like there might not be much happening at the moment. Potentially they're doing some processing on board. When a rover's stationary like this, might be heating up the regolith. Looks like they're discussing some strategy back there in mission control.
There is under 5 minutes remaining. There is a time crunch, high stress levels, and a lot of coordination happening. Some very valuable experience being gained. Once this does wrap up though, don't go anywhere. Shortly after RMIT, we will be joined by UWA on the Space Resources pitch to attempt the Space Resources task. And an interesting view here from the first pitch, the post-landing task with the legendary Rover team.
Grappling there around the back of the lander. interesting situation they find themselves in here. Not sure if they're able to see what's happening. Oh, that's a very cute message in the bottom left camera there on their chassis. Good luck from NASA JPL. Very wholesome to see, again, the international support there.
They're making use of their robotic arm, once again, on the spot. Problem solving, troubleshooting. Great effort from legendary Rover Team.
This is the thing about having a multiple subsystem rover, right? Tangleman, no worries. We've got a robotic arm. Easy peasy. Just another day in the office on the lunar surface, overcoming these challenges that are thrown their way, things that they just couldn't have planned for and predicted. Look at that. We're seeing some impressed faces here in the audience. Ingenuity, guys, at its finest.
Great demonstration of problem solving, facing a challenge you never thought you might face, and getting your way out of it, and resuming their task, which they still have 31 minutes remaining of, so still plenty of time here. This is the final team competing in the post-landing task, the legendary Rover Team. Over here we have RMIT with just a minute and a half left for the space resources task. We're wondering if they've been able to analyze some resources or some of the samples, or perhaps do some processing online. Now, a reminder that all teams are required to give a presentation to the judges right after they complete that space resources task. And once again, a reminder that once RMIT is concluding their space resources attempt, we will be joined by UWA on the same pitch at 3:30 p.m. local time. And that will be the final team that we'll see out here today to compete in one of the tasks as well. And then we'll be wrapping up the second day of the Australian Rover Challenge here today. And what a great time it's been so far. And we're only halfway through.
That's right. I can't believe we've almost seen up to 15 different attempts at these tasks over the last 2 days. And you think we'd get sick of it by now, but I just can't get enough of it. Everything has been completely different. This is such an unpredictable competition. You never quite know what's going to go down, and we continue to be surprised. That looks like an incredibly excited RMIT in the back there. Oh, they look overjoyed. Time's up. I wonder if they got something at the last second. They look absolutely over the moon. There is no exaggeration of their excitement there. Just the relief. Oh, after those initial setbacks, they might have come through with some great points gained. We'll wait to hear back later about how that all went. Well done to RMIT. Next up, we're going to have UWA. You might be nearby. I can see some of their members walking around by the workshop. They'll be on the field in just T-minus 5 minutes time. The legendary Rover Team are going for that infamous hose connection. Let's watch.
A task that we've seen so many teams over the past 2 days attempt. Not easy, and only achieved by a number of Rover teams so far. in the post-landing task. Final stretch for the competition for the second day of the Australian Rover Challenge. As we wait for the final team, UWA, to come out here, and we have legendary Rover Team on the screen at the moment, attempting the post-landing task. And if you're only tuning in now, we are almost at the end of the second day of the Australian Rover competition. This is a 4-day challenge. We're going to be seeing more new interesting tasks over the weekend, Saturday and Sunday. So stay tuned online, or even come out here if you're able to, in sunny South Australia, here at the University of Adelaide Roseworthy campus. This is the 5th installment of the Australian Rover Challenge. Just incredible to see the challenge grow since the beginning, where only 3 teams had participated in 2021. And now we're seeing 15 teams, and even not just from across the country, but a number of Rover teams coming down here from outside Australia as well.
We want to shout out too to the other 2 teams, Swinburne and Rhino Rovers, who have come down here as well as demonstration teams. They still brought their rovers with them. And though they might not be competing, they're still tinkering around and trying to improve their systems. And it was so heartwarming to hear earlier from Swinburne that they've also received a lot of help and advice from the other teams about improving their rover, so hopefully they're able to compete next year. Again, that's just the kind of camaraderie that we love to see here. Even though they are playing for points, there's a lot to be gained and won here just from the knowledge transfer and the friendships formed between teams here. So legendary Rover Team continue to try the hose connection here. Teams were required to design their own hose connection for this part to interface with. So they've all looked a bit different. A base station team there, watching on as our operator uses a trackpad, likely trying to move their robotic arm. That is not easy.
We will note that there are a number of points awarded to the teams if they do have the 2 surfaces make contact. But of course, full points for this task are awarded if the host connection can be made successfully. Will we be seeing that here today as a legendary Rover Team continues making that attempt? And they still have plenty of time with 24 minutes on the countdown. This is the final team completing the post-landing task. We've seen a range of teams do this task, yes, both yesterday and today.
We will note too that the time is 3:30 p.m. That signals the beginning of UWA's allocated time slot to complete the space resources task. They have 40 minutes. Reminder that they can eat into that task time to continue setting up their rover should they need it. And they will be the final team competing today. So while we're watching Legendary Rover Team with their attempt, we're going to prepare to cut over again to Profay, who was backstage in the Rover workshop. She'll interview another team. Profay, how's the vibes?
Isn't that waiting for the hose connection?
Just watching the hose connection still before we throw over to an interview here.
While Legendary Rover Team is still attempting at the host connection, let's quickly cut to Profay, one of our commentators who's in the workshop at the moment, and let's see what some of the students have to say from the other teams.
I've got Cal with me from UQ Space. Hello, Cal. Could you please tell us about what's going on with your rover? And I know you guys just competed, so maybe you want to start off with that.
Yeah, so we competed earlier today. We entered into the Lunar Resources task where we were able to successfully extract water as well as image and detect ilmenite. So we're quite happy with the success that we had today. Hopefully a lot of the other teams have done well with their water, but we're quite confident that we've extracted a good chunk of water as well. So hoping for a bit of competition there.
Yeah, congratulations. It did sound like that you guys had collected a lot of water, so very, very excited for that, for the results of that. Could you please tell us about the design of your rover, as well as what are these pavers doing?
Yeah, absolutely. So at the moment we're preparing for both the space construction and excavation tasks tomorrow. So in front of us we can see the pavers on the ground. So these are actually so that we can build a nice rover roadway or highway during the construction task, as well as the excavator mounted on the front of our rover, which we just mounted actually to excavate the regolith that will be required.
Is there a reason why you have such a large excavator?
Yeah, we were quite impressed with the amount of strength we're able to get out of our dynamic payload mount. So you may have seen this morning that the bracing on the back where it can move up and down is very similar to this morning's. It's because it's identical. So we're able to swap out the extraction system we had with the excavator bucket you see on the front. And we originally tried with quite a small one because that's what we had worked out would be needed, but then we found that we'd kind of gone a little bit overkill and went a bigger bucket was able to get us more dirt, faster time, so we're able to really improve our speeds there.
Yeah, sounds great. And just one last thing, I also see that your suspension and wheels have a very special and a unique triangular design. Is there a reason behind that?
Yeah, so we use a 6-wheel configuration in a rocker bogie setup. Basically that means we get 6 points of contact at all times with our custom TPU wheel. So we printed those to give us as much grip as we can, as well as giving us a little bit of compliance, so that if we did get a little bit bogged, we'd have a little bit of resistance if we just kept spinning. And it means that at high speeds as well, we get quite a nice spin and can keep moving and just basically float.
Yeah, that's really great ideas. Thank you so much. We will be back with another interview very soon.
Really interesting explanation there from UQ Space. And a nice sneak peek at their tile system. That's something we haven't talked about yet. In the excavation and construction task tomorrow, as well as doing exactly what the namesake of the task is, teams are also required, if they choose to lay down a path of tiles at some point during the challenge. And they have certain dimensions that they have to adhere by. So seeing their approach to that tomorrow is going to be really interesting. Again, just adding to the complexity of this challenge, yet another system that the teams have to design. As we go back to Legendary, attempting the RFID reading on that processing plant.
We've seen them attempt the host connection just early on, and it was really a moment of suspense that has built up there. But they've moved on from that, heading to the processing plant, and at the moment it seems they're attempting to get those instructions through the RFID task from that card. Not wasting a single minute since they started, Legendary Rover Team has shown a tremendous effort so far, and it's still just 18 minutes. Lots and lots of time for them to accumulate incredible amount of points. potentially moving them up on that scoreboard or leaderboard, which you can check as it gets live updated on the website, the Australian Rover Challenge website. Otherwise, stay tuned here. And as the judges continuously weigh those results in, we'll be displaying them on the screen as well. We've seen about 14 rover teams attempt or at least complete some portion or fully the post-landing task here. Some of them going for that keyboard task, as we see here on the screen, and some of them strategizing and going with other tasks, as we've seen before. Here we have the final team to attempt the post-landing task, the legendary rover team, who still have enough time. We will be seeing some action.
And if they have downloaded those instructions successfully, they will be trying now to attempt the maintenance required to fix that processing plant. We've seen a few teams pull this off. If you get agonizingly close, check out the manipulation of that joystick there. Very impressive. The ability to be able to hold on to something like that. Again, using a robotic end effector to get the spatial awareness required to pull that off.
Incredibly precise movement from that end effector of the robotic arm by the legendary rover team. I believe this is the first time we've seen a rover team successfully using a clamp or claw grab that leverage system there on the processing plant and move it around. Over here we have UWA, whose countdown did start about 9 minutes ago for the space resources task. They seem to be troubleshooting at the moment, so once again, these are really critical times of on-the-spot problem solving, troubleshooting, team coordination. They still have 30 minutes remaining to complete the task. So if they can get that rover up and running successfully and on the pitch, ready to go, they may be able to get some good amount of points before the end of the time. And this is the final team participating today, not just for the day, but also for the space resources task. So just like we mentioned before, on the weekend, you'll be seeing a very different overview of what's happening in terms of the tasks. So the first 2 days so far have been focused on the post-landing task, which is simulating your rover has just landed on the moon and needs to do a systems check, and simultaneously on the second pitch, a space resources task, which is where your rover will need to be able to prospect some samples and analyze and extract and process, if possible, those samples and extract some resources. Over the weekend, we're going to be having excavation and construction, as well as mapping and autonomous on these two pitches. Very different challenges, and really excited to see how these teams are going to be adapting those rovers and adapting those subsystems and coming out here to have a go at those new tasks.
Cut back now to legendary rover team. Some of the final stages of the processing plant maintenance. Wow. Can they do it? we see some movement on top of the processing plant. Got some claps from the judges. That looks like a successful job. Well done to the legendary Rover team, who have fixed the processing plant, and look at the top there, whirring around, indicating that that processing plant has come to life. One of the major tasks required by teams for the post-landing task. With 12.5 minutes remaining, I'm going to check back in on the legendary Rover team, but we do have another interview lined up with Profay over in the Rover workshop. So when she's ready, we're going to throw to her, and then come back to the legendary Rover team. Hopefully UWA will be able to diagnose the problems, and we'll see them out there on the pitch as well. So whenever Profay is ready, we will cut over to her. See who she's got lined up to chat to.
Hello, welcome back. I have Patrick from UNSW Canberra with us with their rover. Patrick, could you share a bit about your rover design and what you're working on right now?
Yeah, awesome. So this is our rover named Marvin. What we're essentially doing now is just resetting from today's post-landing task. So we've got the arms stripped off from our front, and we're getting ready to put our scoop back on and get that tested. Yeah.
Yeah, it looks great. And you were talking to me about the simplicity of your rover. So, as I can see as well, your rover cube base?
Yeah. Do you want that? Yeah, easy. Yeah, easy. So what we'll decide, if you bring the camera here and you can have a look in, all of our components here are fully modular and able to mount on DIN rails. So we've got our network switches, batteries, that's our computer, Jetson AGX Orin 64 gig Dev Edition. We've got our CAN bus board there, little PDB. There's another power distribution board over here. We've got our screen here, which we use for dev, which makes it a lot easier for us to just essentially, if we have a problem, we can just plug straight into that computer, have a graphical interface, work out exactly what's going wrong. Our antennas, our radios up here, we're running a 900 megahertz and a 2.4 gigahertz setup. So all of our controls and commands from our controller go through that 900, so we get better range, lower latency, less issues with dropouts. And then all of our cameras go through the 2.4 here. In terms of additional modularity as well, we've got our T-slot aluminium rails on the front, which everything's mounted to. Makes it really easy to swap stuff in and out of. DIN rails run through in the middle, and each payload has its own package with a single 2 voltage regulators and a PCB for that. So, yeah.
Thank you so much for that introduction. That was amazing. And I'll be back soon with another interview.
Thank you, Profay. And cutting back here to the legendary Rover team, it seems they're having an attempt at one of the other host connections here at the processing plant. And what a sight to see. 10 minutes remaining and a tremendous effort all the way from the beginning and all the way till the last minute, I'm sure, as the last team completes attempts at the post-landing task. Will we see a successful host connection here today? That is the big question. One of the most critical tasks in the post-landing task. Look at that view that the base station can see from their monitors, that live camera feed. Really making use of those degrees of freedom on that robotic arm and that claw. Strategy is really key here. in trying again and again, perseverance, which is what we've seen demonstrated from all the student teams that have come out here to compete in the Australian Rover Challenge, running for the 5th time here at the University of Adelaide Roseworthy campus.
Earlier, Shagaf, you were talking about the excavation and construction task tomorrow. I think something that might be really interesting for audiences, or they might have been thinking about as we were talking about, is that sounds like a lot of civil engineering, potentially an area that you wouldn't expect to see here in a heavily space and mechanical engineering environment. But in fact, civil engineering is one of the most important areas of development for future lunar missions. Calling back to the Artemis objectives for establishing a sustained human presence on the lunar surface, just like building a house, you need some kind of foundation to be able to build structures that humans can inhabit. And a lot of that comes down to fundamentals of civil engineering, which again, the teams are going to be tested on tomorrow in the excavation and construction task. Being able to lay down paths and tiles could be essential one day for astronauts to be able to navigate between sites. And on the lunar surface, these sites could be tens of kilometers away from a main base station out to a potential resource site. And so being able to clear an area, doing that excavation, then being able to lay down those foundations with the construction aspect, they're all critical skills, just as important as some of these foundation systems as well, like we've got here in the post-landing task.
Now, with just over 5 minutes remaining, we might cut for just another interview as well. There's a lot that these teams want to talk about and say this afternoon, and it's been such an interesting showcase of the workshop and the atmosphere there. So whenever Prefet is ready, we'll cut to you for another quick interview before we come back here.
All right, welcome back. I've got Hunter here with me from the team of UOW. Hunter, could you please talk to us about your rover? I think your team is the only team with 2 rovers. So what was the thought behind that?
So we were sitting there last year after competing in the post-landing tasks, and we were watching the live stream, and we realised all the teams, like the best teams there, were time troubles, you know. So they were doing half their system for one, and they couldn't have time to complete the other. So we thought, let's put in an auxiliary system that we can multitask with.
That sounds really great. And I know your little rover is named Roo. Was that after Rover?
And that afterwards, there was a happy coincidence. During that chat, we were remembering names, and we came across like Winnie the Pooh on like it's the meme or something, and we're like, okay, we have Kenga and Roo, which is named after the kangaroo family in Winnie the Pooh.
That is so cute. I love that story for you guys. All right, so are you guys here? Could you tell me what you're working on?
So right now, we're actually working on the pouch for Roo. So we need to make sure that we leave as an entire system. Actually has to start on Kenga, and we start on it inside the pouch. We lower it down so that Roo can then.
That is the cutest story I've heard today. So yeah, I wish you guys best of luck, but I will see you with another interview later. Bye.
Awesome stuff. Thanks, Prefet. And it's really incredible to hear them talk about the story behind that mini rover, which Georgia and I just absolutely freaked out over when we saw for the first time demonstrated yesterday here on the first pitch. Coming back to the legendary rover team, 3 minutes remain as they go back to attempt one of those previous tasks as well. And honestly, such a magnificent effort from this team. They've gone all around, attempted tasks. Some have been successful and some have not. But really the effort and the perseverance that they've put up for the entirety of that 40 minutes has been inspiring, truly incredible. a moment of suspense builds up as about 2.5 minutes remain for the post-landing task. And this is the final rover team to attempt the post-landing task for the Australian Rover Challenge 2025.
Just 1 minute 30 remaining. Legendary Rover Team all the way from Poland. Here in South Australia, less sunny now, more cloudy as we head into the late afternoon. A huge day of rover action. If you joined us on the live stream at any point or come out here in person, we can't thank you enough for your support of this challenge. Tell your family, tell your friends. What else are they going to be doing this weekend except tuning into this live stream? I know there's an F1 race on Sunday. Surely have both screens up at the same time. You'll see as much action here as you will on the racetrack.
What a moment of suspense. Not the first one that we've seen today with under a minute to go and still that effort. High and bold. One final attempt from the legendary Rover team for the post-landing task. What a moment of suspense. We are freaking out here at the commentator's booth, but unfortunately that is all the time available for the legendary Rover team. And a round of applause from the crowd there. Incredible work. That is just monumental. The effort in that last second and that suspense that really did have us catching our breath over here.
Monumental effort there. So close on that hose connection. What an interesting approach too. You could see the way that it almost molded around the other side of the hose connector, reducing the accuracy needed to get that connection. But that elbow connector looked really tricky to position, potentially causing some problems over just a straight angle there. So close, but an amazing attempt by the team. I believe they are pretty close to full points for that post-landing task. Hopefully we'll be able to see a bit of an updated leaderboard later.
Now the final team we have participating today is UWA, who will be doing the space resources task. And they have been absent for quite some time. We've been wondering where they are, but here we go. Showing up with their rover loud and proud. They're coming onto the pitch now to get set up. Now they did have 40 minutes available for this task, which did kick off at 3:30 p.m. local time. So their troubleshooting did eat into their available time. But they do have 13 minutes on the clock there, and that could actually be enough time to get enough points to make that difference. And here we go. Will we be seeing some last minute action today? This is the final participation that we'll be seeing for the second day of the Australian Rover Challenge, the 5th installment of it here at the University of Adelaide Roseworthy campus.
Just as we saw earlier with Monash Nova Rover, it ain't over till it's over. until that timer clicks down to 0, they can use it however they need to try and get some points. Again, a reminder, the iSpace Space Resources task, these are the 100 points up for grabs. Prospecting the sites and imaging them, excavating and processing a sample from a chosen site believed to contain the most amount of water content, and a presentation at the end where the teams will show off their knowledge that they've gained about space resources. UWA, we see some movement here, hopefully a positive sign that they can get to a side as we count down to 10 minutes remaining. Rounding out day 2 of the challenge.
Just a reminder once again, this is only just halfway through the Australian Rover Challenge. Over the weekend, we're going to get some more action, exciting events happening with 2 very new tasks that these teams will be up against, the mapping and autonomous task and the excavation and construction tasks. These pitches will look different, the challenges will look different, the rovers will look different. Everything will be new. We cannot wait to see what Saturday and Sunday has in store for the Australian Rover Challenge. Stay tuned on the live stream, and if you can, come out here, join everyone that's come out here in person, witness this incredible show in the flesh and bone. Chat to the teams in the workshop where they are right in front of you working on the rovers. Even come up and see the mini rover up close. I got the chance to do that earlier from the University of Wollongong. And even come talk to our industry sponsors and supporting partners. Come have a chat to them at their booths as well. Just an exciting time all around. Expected to be much busier on the weekend as well.
All eyes on UWA now. Looking at their GUI there. Looks like they may be having some issues with their camera feed. Or potentially still waiting to establish a bit of a connection. They're using a WebRTC pipeline. Something that's quite complicated to learn. To be able to get that live camera feed happening, they need to be able to establish a data pipeline to be able to stream images from that camera to the base station in enough real time with as little lag as possible so that they can drive that rover around the pitch. And if they can't see the camera feed, like we've said throughout the day, as one of the crucial components for the base station team. Oh, and it looks like they've got one front camera there working. So those are the eyes that they are looking through, trying to locate some sites, potentially complete some prospecting if they can.
Great demonstration of that drive traversing across that terrain. And a rather simple design here than the rovers we've seen. A lower clearance between the chassis and the ground in that unique wheel suspension design, and a very clean and tidy boxed design of the rover there.
I'm interested in these tyres as well. I don't know if those are 3D printed. They look like they could be real tyres. Something you might find on an RC car or something like that. Close up there with those tyres. Could be something commercial off the shelf. Another term that we use a lot when we're talking about space technology, COTS, commercial off the shelf. Something that's emerged with the sort of new space age that we're seeing over the last decade. You can actually buy whole spacecraft components and assemble them together to build a satellite. And I'm sure one day, when lunar missions become more regular, we will see a very similar thing with rovers, off-the-shelf components. These tyres may be an example of that. Challenges here with just having that front camera. Can empathize with the base station team right now how difficult this is to be able to drive around the course. Very narrow field of view there. They're going to be doing what they can to be able to see the sites that they have to travel to. Not being able to see the rest of the rover either, to get that all-important situational awareness. As we head into the last 5 minutes of day 2. We're hearing now that we're able to get an updated leaderboard for you as we close out day 2 of the challenge. Let's bring it up. Wow, check that out. We've said before, you can never predict how these scores are going to change. And if you thought it was close before, look at the top 4. 3 points between first and second, and just 1.5 points between third and fourth. Wow, this is cutting it close. Even then, just at 4 points between fourth and fifth, a handful between fifth and sixth. And you look down in that top 10, there is not much separating those teams. Amazing job by everybody. Distribution, the Polish teams kind of sandwiching that leaderboard there. Again, all to play for tomorrow with excavation and construction, mapping and autonomous, and AGH Space Systems still in pole position up there in a tentative first place, followed by UQ and Monash Rover rounding out the top 3.
Three minutes remaining in a moment of suspense, as we've seen UWA's rover roving around, trying to accumulate some points to make the most of the time they have left. They did face some setbacks at the beginning of when the countdown started, and they were absent for a while, troubleshooting their rover, hard at work coordinating. What an incredible 2 days it's been, halfway through the Australian Rover Challenge, and the teams should be incredibly proud of themselves for making it this far. The next 2 days will bring on new challenges, and I'm sure the teams will be hard at work tonight, tomorrow early morning, and even in the following days, preparing, troubleshooting, coordinating, problem solving, developing, fixing, and all of the above. What a magnificent 4 days, and what an incredible opportunity for them to gain that valuable experience, to talk to industry professionals from our sponsors and partners, and to get this hands-on real-world problems, not just any real-world problem, one of the most difficult rover challenges from all around the world that we've seen. These are undergraduate and postgraduate students designing and developing and building and operating these rovers in their own spare time. And we've said before, congratulations for just even making it out here, even to the teams who didn't get a chance to participate, the teams who came out here for demonstration purposes, who may have faced some issues or setbacks. And now just a minute and a half left to go before we wrap up officially the second day of the Australian Rover Challenge 2025.
Just 20 seconds remaining now, 15 left to go. That timer is ticking down. Amazing effort by UWA. They got out onto the track. And as we close up day 2, an impressive effort by the team. Give them a round of applause. High fives all around in that base station. Great attempt, I'm sure a lot learned about their rover today out on the pitch. We saw the leaderboard before. We'll be getting some of those scores from the Space Resources task coming in overnight, hopefully for another updated leaderboard in the morning. As the team come and collect their rover off the field, rounding out day 2 of the Australian Rover Challenge for 2025. That is the University of Western Australia heading back to the workshop. So just to say again, for everybody who came out today, sitting in our audience, joining us on the live stream, supporting from around the world, thank you so much for joining us for day 2 of the Australian Rover Challenge, and we really appreciate all of your support and comments. Keep the love coming, keep the support for the teams coming. There is so much more to see over the next 2 days.
Absolutely, and it's been an incredible privilege for the both of us commentating and taking you through what's happening here at the Australian Rover Challenge, particularly being part of the challenge and being on that end. We know what it's like, and it's been an honor just taking you through and commentating and having this opportunity. And this will be everything from me, so it's been an absolutely amazing experience. I'm hoping that you enjoyed, and I'm hoping that we haven't talked too much on your live streams, and I'm sure the teams are probably annoyed from our voices by now. Georgia will probably still be around, but tomorrow and the day after there is a completely new lineup of commentators who will also, I'm sure, do an incredible job taking you through the day. That's all from me, signing off. This is Shagaf and Georgia, and we hope you have an incredible rest of your evening and happy weekend. We'll see you back here tomorrow.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.